hard-to-reach populations or marginalized populations, there's, I think, an argument here that probably the most hard-to-reach populations, they are not literate enough to send a message through SMS. So maybe you don't want to talk about hard-to-reach, but we'll talk about difficult to reach. So we can think of Somalia as a context with difficult access and with some problems in terms of access in the field, problems in terms of the security. This interactive radio and SMS method will allow us to communicate with these communities at a distance without being there presentially. So it will present, I think, very quick gains in the case that you have to respond very rapidly in a case of an outbreak. So this case study, that is what this project is about. The objective is to evaluate the use of interactive radio and SMS as a means to understanding the social perceptions of cholera risk and preparedness among communities in the south-central zone of Somalia. We have different outputs. We have academic outputs, but one of the outputs is to prepare a protocol for other organizations or other research projects using this method in the context of a health crisis. So just in terms of the project overview, so as I said, the project was focusing on the south-central region of Somalia, mainly 4 different towns. And in these different towns, we had radio stations, around 10 radio stations in total, that broadcast a weekly radio show for 5 weeks. So we received in total 12,000 messages from 7,200 people. So the number of messages per radio station really varies. In some radio stations is 30 messages a program, and other radio stations we can receive 200 or 300 messages. So the radio stations were chosen in a way that we can cover most of the communities that we are interested in. And also as a way to evaluate this interactive radio and SMS method, we undergone some research using other methods. So the same questions that we ask on radio, we ask the same questions through call centers. So we had the numbers of people in the community that were a representative sample, where people were reached through their phones, and the same questions that are asked on the radio, they were asked one-to-one. And of course, this group were different from the group that were participating in the radio shows. And finally, we have a third method. There was the focus groups discussion with groups that were comparable to the groups that were participating in the radio show. The idea was to understand what is the potential and what are the strengths of the interactive radio and SMS as compared to focus group discussions for call center research. And here you can see, this is a map of the questions that we ask on here. So we had 5 weeks of radio shows, and we have questions related with the risk of cholera, with the cholera preparedness, with the perceptions about the response of cholera in the last outbreak. So all the questions that you see in pink are the questions that are asked on here. So we have a radio show of about 30 minutes where there's an introduction to the problem of cholera by an expert, someone who is reputable and trustworthy for that community. And then we have some questions to the audiences. For example, we would like to see if you think that we'd like to know if your community is at risk of cholera, and yes or no, and why not. So this format is a format kind of standard for Africa Voices, because we did some initial research and we thought this is the type of question that elicits more discussion. So in the radio shows, we don't ask anything personal about about the audiences. We ask about the community. So all the level of inquiry is the level of the community and not people. So this also protects us to problems related with confidentiality of information. We are not asking anything confidential during the radio shows. But when people answer these questions in the radio shows, that triggers a cascade of other messages that are more one-to-one. So we want to know some demographic information about these audiences. So people who send these messages, they will receive automatic response asking questions that you see in yellow related with their gender, their age, their location, and whether they are internally displaced people, and where they are coming from, and so on. And apart from beyond these questions that are more demographics that you need as a kind of a dimension to interpret the data, we also have more short kind of answer questions related to, for example, if people were vaccinated or not. So that question about vaccination was particularly important because there was some cholera vaccination campaign in 2017, and you wanted to understand in that communities if the campaign reached them and what would be the connection with the community health beliefs in those communities. To understand what are like the beliefs that show some resistance to these vaccination campaigns. And this is a scheme that shows what is our data flow. So we have these questions that we ask on radio, and then from these questions that trigger other questions. So participants will receive these follow-up surveys, and with these follow-up surveys, we collect all the data and we analyze it to understand what are these community health beliefs and how these vary depending on gender or depending different age groups or the education. And then we analyze this information and we present it in a visual, engaging and interactive way for our partners that we are working with. For example, we were working with UNICEF Somalia for this project. So we work with teams that we expect to take the learnings and the insights from this research forward and they use them to inform the next stage of the preparedness for a cholera outbreak. So at Africa Voices, we combine different types of knowledge. So we have the data science combined with social science and combined with the human knowledge. This human knowledge is more related with the language knowledge and the contextual nuances of the language. So from the data science side, we need to prepare the data, we need to parse the text, we need to construct visualizations. In this respect, we at Africa Voices, one of the collaborators of this project, Dr. Luke Church, built an interface to code messages called Coda, that the messages, that when we receive the messages, they are all in Somali and with some dialect. So we have some Somali research assistants reading the messages and coding the messages. This will be very time consuming if it needed to be done in an Excel file. So this is done in an interface where the messages were coded into one of our categories of the coding frame. It generates regular expressions that will allow to guess, to predict for other messages what will be the category that they belong. So as the research assistants are coding the messages, subsequent messages are going to be automatically coded, and they just need to validate the coding that was done. This was not done yet with machine learning, but that will be the next step, I believe. So we combine this knowledge and these tools with social science in terms of the social science, the social research frameworks of social psychology or public health, to understand the way that people are talking about these health outbreaks. And we use some knowledge in terms of communications and in terms of engagement when we develop the scripts for the radio stations, or when we, for example, analyze the volume of the messages over time. We know that there are certain types of patterns that we expect. In terms of human knowledge, we have the research assistants that, as I mentioned, they are native speakers, but they need also to understand sarcasm, they need to understand like these contextual specificities of the messages. And now just to give you a flavor of, so this is the kind of the interface that we use, is Rapid Pro to get the messages. So we receive the messages, and then we have the raw messages and the raw follow-up questions. And then we merge them into a data set that is automatically cleaned, and then we code messages with this coder, and then we have the data set to analyze. So, okay, this is the example of this interface coder. So I think the main point of this interface is to be efficient in terms of the coding process, to reduce the time that is needed to code all this data. This is just what is the different pattern of the volume over time of the message that we receive. And here I would like just to highlight that this is not only a matter of people don't participate only because they are listening to the radio show and they have access to the mobile phones. There are elements that we can introduce in the radio shows in terms of techniques to engage different, to engage, for example, women in the discussions that really make a difference in terms of the volume of the messages that you receive. And finally, this is just an example of the messages that you receive for the first question, if you think that people in your community are at risk of color or not. And from these messages, we aggregate them into these different themes. So we know that people say, no, I don't think that we are at risk because we have proper hygiene, or people say, yes, I don't think we are at risk because people are not aware enough, or because of hot weather. And finally, I would just like to list some of the challenges that we have in terms of the language. In terms of data processing, we are not still at the stage that we can automate all these textual data. So we have a lot of actions that are done manually, especially because of misspellings, dialects, and so on. In terms of analysis, we also need to do more research to understand these idiomatic expressions or irony or sarcasm. In terms of the credibility, we have done already some research to triangulate this method with other methods to understand what are the weaknesses and the strengths. But there are also challenges in terms of interpretation, in terms of presentation, ethical challenge, and also to collect data that is not self-reported, for example, geolocation or the data related to social networks. And yes, so that's the presentation. I will be very happy to answer any questions that you may have. Thank you.
Thank you very much. We have time for questions.
Hi, Claudia. I'm Jenny Fiedler from Public Health Network. So I was interested to see that in the different research groups that you had, there weren't any health people involved. Can we consider ourselves beneficiaries? So do we come under the last one of your groupings?
Yes, I believe so. I think public health. We have the research lead is a public health researcher, and we are working with UNICEF very closely in this project. But I think all health practitioners and organizations will be considered stakeholders and beneficiaries for this type of research, and that's what we hope to do it with this protocol, so others can use the learnings and know how to implement the tool for their own research or practice.
Like for the current Ebola outbreak?
Yes.
Thank you very much. It's great to hear something totally different to what I do. But I was wondering how you evaluate consensus. So I was interested in your slide where you had the bubbles about people saying, no, we don't have a problem, or yes, we do have a problem, and just reflecting on if you asked on a radio show today, will Brexit be a total disaster? Half the population will say yes, and the other half will say, no, it'll be fine. So how do you then take that information where you don't have consensus and make a principled decision about how you will act in that area?
Thank you very much. It's a very interesting question because that's the point that we are at the moment, and we are asking that question ourselves. So we just received the data and we are trying to analyze the data in any way, and what you want to move away is from presenting this data in terms of percentages. So I didn't put up numbers, we just put bubbles because we think we need this agreement. Even we have these kind of demographic groups, men, women, age groups, and education, but they are not necessarily the groups that will have that will find most agreement. We can have agreement of the community health beliefs, for example, in a family or extended family with people from different age groups and probably different levels of education. So we want to understand how these community health beliefs they spread along these networks, and we don't have yet data on these networks that we hope we will have. I think for the time being, probably we are going to use a kind of a multi-level approach for this data, that we have more individual level and more community level. So the beliefs, they are not going to be assigned to individual, they are going to be assigned to one of these communities. And then at individual level, we have these key demographics and health information, whether, for example, individuals are vaccinated or not, and try to look at this interplay of the individual with the community.
That your project is very much about the sort of interaction between local community and health experts. But so at the end, you mentioned the possibility of using the GPS signal in phones and reconstructing networks, social networks. And since obviously the social networks will give you sort of disease vectors and so on, that would seem to be a very important aspect of this kind of work. It does offer you an objective pattern of the community in some way, and also with dialect, because if people come and code those kind of things, you would also get some interesting network patterns, and it might be very practically important.
Yes, I completely agree, and that is possible if you have access to the mobile network information, to call the record details. So we could see for the people, because we have the phone numbers, we disguise them, we change them, so for privacy, we don't work with them, but they are stored in the first place in the Rapid Pro. So what's possible maybe to link this data to call data records to see what are the phone numbers that are connected to each other in terms of messages and calls. That would be amazing. I think we are planning to do something similar to the next stage of this research, that we are bringing big data. We are still identifying what is possible in terms of these big data sources in Somalia, or even in terms of administrative data from health centers, and try to map it onto our social insights from this research to see how they are linked together.
Thank you very much. Okay, and now it's time for the poster slam session. I would like to invite Samantha Z and Joyce Lim, who are the PhD students who are going to organize the poster presenters. The one thing I want to say is that some of the projects that are going to be reported are supported by the Incubator Fund, which is a small fund that is offered for interdisciplinary research by Language Sciences IRC. The collaboration of the audience in this poster slam is very much needed, so please pay attention and enjoy.
It's working? Ladies and gentlemen, each presenter is about to describe their work in exactly 1 minute in one slide. Now, I understand your desire to show your appreciation to them at the end of their talk, but instead of giving them a long applause, which is pretty time-consuming, why not try a power clap, which is one clap after each content slide. This is also to test if you're concentrating. Now, let's try the power clap all together. Ready? In 3, 2, 1. Well done. Right. Now remember, at the end of each talk, one power clap. Without further ado, let's invite our first presenter, Andrew Keynes, to share his projects with us.
Thank you. Okay, so I have the dubious honor of going first. That's because this session was ordered alphabetically by the poster titles. That teaches me not to use the word A as my first title, and to, oh, it's not up there, but my title begins with the word A. I should have used the, but it would have sounded arrogant. Anyway, so apart from eating into my time, I want to say that I have 3 posters. They're all to do with the Incubator Fund. I want to say thank you for that, because it gives us a chance to do cross-disciplinary work, go out of our comfort zone, talk to other departments, etc. So thank you for that. We worked with education faculty, computer science and MML. And in this case, we funded 3 undergraduates to do internships over the summer. One of them was a literature review for the new Language, Brains and Machines Research Network. The second was developing a literacy and numeracy testing and teaching application. And the third was a gamified approach to linguistic data collection. Okay, so please come and see my posters. They're all in the same place. They're all by the exit, so you can't get away without seeing me.
Next, we have Angie Wilson, who will be talking about developing prototype assistive listening technology for remediating developmental dyslexia.
Developmental dyslexia children struggle, as we heard, with identifying and manipulating parts of language. And as we heard a little earlier also, that seems to be associated with problems and impairments in processing low-level modulation frequencies. In our project and our poster, we're going to be showing how we might target some form of intervention, and we're going to boost the low-level frequency content of speech, and we're going to present that in 2 ways, one with general literacy material, and also with a rhythm and music poetry intervention that we've also found successful earlier. We're going to also use EEG and MEG to look at the impact of the interventions. So do come and see us. We're slide 3 if you'd like to know more. Thank you.
Up next is Guy Anderson, who will be talking about functional distributional semantics, learning linguistically informed representations from a precisely annotated corpus.
The aim of distributional semantics is to learn the meanings of words from a body of text. I put up here 6 examples of the word pepper from Wikipedia, and if you didn't already know the word, you could learn from these examples that peppers are things you can grow, that you can cook, they have genomes, and so on. And at the bottom of the slide is one way that you might want to represent the meaning of a word as a function from entities to probabilities of truth. So the green, yellow, and red peppers are definitely peppers, the carrot and cucumbers are definitely not peppers, and for the purple and blue ones, maybe you're not so sure. How can you relate that to learning from text? Well, come to my poster to find out.
Then we have Marika Malin, who will be sharing with you about creating a corpus of multilingual accounts from London Bridge 1380 to 1480.
So for our incubator project of 3 weeks, we created a procedure to annotate a historical multilingual corpus of the London archives. And we don't really know how the English language was standardized, but we do know that in the 14th and 15th centuries, there were 3 languages, Latin, Anglo, Norman French, and Middle English, that were mixed in those manuscripts. Plus, there were all sorts of complex symbols and abbreviations in the manuscripts that have important linguistic clues. So we started a procedure by normalizing the text, preserving these linguistic clues. Then we used a memory-based tagger to annotate both the language and the part of speech, and we combined everything together. So if you're interested in how you can see all the complex London archives, or if you're interested in creating a multilingual historical corpus yourself, please come and see our poster.
Next, Hui Yuanxie will be presenting how clever are the models exhibiting superhuman performance on VQA datasets.
Hello, I'm Hui Yang from the Computer Lab. Recently, many AI models have been reported with very high performance on various tasks. Visual question answering is one of such tasks. But have you ever wondered, are those models really that clever, or are they simply taking advantage of subtle biases contained in real-world data? For instance, simply answering yes to all yes-no questions on real-world data would result in an accuracy of more than 70%. This is why we think there is a need to use artificial data, controlled data, to evaluate how well computational models understand different language patterns. We got a number of quite interesting findings, so do come to see our poster to find out more. Thank you.
Then we have Jingting Xiang, who will be presenting to you about indefinite NPs as subjects in L2 and L3 Mandarin grammars.
Our current world is no longer a world of bilingualism. A large number of people, and I'm sure that includes you, speak more than 2 languages. With a third language, a natural question is in what way 3 languages interact with each other in one human mind. Our poster presents a comparison between the processing of Mandarin as a third language by Cantonese English bilingual speakers, Mandarin as a second language by native English speakers, and Mandarin as a first language by native Mandarin speakers. And our data tells a story about one of the major tasks in research on third language acquisition, that is to identify which previous language, the first language or the second language, plays a more prominent role and why. Thank you.
Up next, Olivia Goodman will be talking about indirect corpus applications, collecting data and using it in ELT materials development.
Hi, so quite a few years ago I was talking to my Spanish friend and I said I was hungry and fancied a snack, and I used the word tentempié, and she laughed and said I sounded like her grandparents. I was embarrassed and I wasn't sure what I'd said wrong, and when she told me, I realised that I'd learnt this word from my school Spanish teacher who hadn't lived in a Spanish-speaking country for over 20 years. So had she been teaching me outdated Spanish, the Spanish that she had learned many years before? And as a student, I trusted that I was being taught the most relevant and useful language. And this happens time and time again, and we all know that languages change over time. But what exactly has changed? So to address this in English, we collected a corpus of spoken British English, the BNC 2014, analysed it and compared the findings with the BNC 1994. And now we've used these insights to inform our ELT course materials so students and teachers are exposed to relevant, authentic and natural English.
We then have Silvana Mareva, who will be talking about inter-symptom relationships across linguistic, cognitive and behavioral problems in a developmentally at-risk population, a network approach.
Hello. So symptoms of hyperactivity and inattention commonly occur with language and communication difficulties, both in clinical samples as well as in typically developing children, but the mechanisms and the specificity of the relationship are not very well understood. To investigate this, we looked at a sample of children with both diagnosed and undiagnosed learning difficulties, and we applied a network analysis approach. And here you can see a summary of our findings. In this graph, you can see parental ratings of difficulties in the nodes, and the edges between them represent partial correlations after you account for all the other difficulties that the children experience. And we also applied a community detection algorithm in this graph to find clusters of difficulties, and we found 4 clusters corresponding to learning a structural language, pragmatic difficulties in peer relationship, halt reflective difficulties, cognitive or cool difficulties. To find out more, you can
After this, we have Courtney Frolick, who will be presenting her work on investigating mechanisms of change in children's social attributional thinking, a frame semantics approach to social cultural discourse analysis.
Sarah sees the new student sitting alone on the playground and says to her friend, "He must be a loner." This is correspondence bias, the tendency to attribute someone's behavior to a personality trait or a disposition without properly considering the context. We know this biased attributional thinking develops between 4 and 6 years of age, and that it's a precursor to social stereotyping. I wanted to know how we might intercept the emergence of this bias. So I partnered with teachers in Cambridge to work towards broadening children's social thinking in the context of dialogue around stories. I deconstruct this dialogue through a unique combination of frame semantics and sociocultural discourse analysis. I hone in on the shifts in frames of understanding and the ways in which teachers move children's thinking away from, "He's naughty, she's nasty, he must be a crybaby," or a loner, to more nuanced explanations of behavior and perhaps more open-minded understanding of others.
Next, Kylie Clarkson will be sharing with you language processing of personal beliefs.
We know that during language processing, a semantic mismatch leads to a brain action that we call the N400. And this is basically your brain going, "Eh?" And what we at the Believing Brain Project want to investigate is how our personal beliefs interact with our language processing. So we want to ask questions such as, when we hear a sentence, such as one at the top there, where that one word causes the meaning of the sentence to contradict our religious beliefs, do we see an N400 in the same way as with a semantic mismatch? And does the very personal nature of belief lead to changes in frontal alpha asymmetry, which we know is an indicator of emotion? And do we see differences between the processing of statements of belief and statements of fact? And if you'd like to know more about how we plan to investigate all of these questions, please come to our poster.
Then we have James Algie, who will be talking about L2 English genitive choices of L1 Spanish speakers.
Thank you. To express the possessive relationship between two noun phrases, English allows two broad types of construction: Saxon genitive construction on the left and prepositional construction on the right. So we have the equally acceptable phrases, the future of Britain and Britain's future. Conversely, Spanish allows only one type of construction, and that's equivalent to the prepositional construction in English. The two English constructions, however, are not always interchangeable, and the key determining factor in the native speaker's decision is the animacy of the possessor. That explains why Mary's bike is preferable to the bike of Mary, for instance. Given this semantic complexity and the cross-linguistic variation, it's unsurprising that native Spanish speakers struggle to acquire the Saxon genitive in the early stages of learning. So to find out how these struggles persist into the latter stages of learning, come and see me at poster 13.
Up next, Lê Nguyen will tell you about matrix language variation in Canberra corpus of Vietnamese English code switching.
So code switching is a phenomenon when a speaker uses more than one language in a single utterance. So for example, what did you học at school tonight is a Vietnamese English code switching sentence, which means what did you study at school today? So my research looks at the structures in clauses. Do grammar of language A and language B contribute equally to the structures of the utterance? And if not, how do we identify which language contributes more? It's also explore whether the changes in the grammar of bilingual speech changes over time and it passes through generations. So in order to answer these questions, I built an original corpus of conversations from Vietnamese English bilinguals living in Canberra, Australia. 46 speakers, 90,000 words, 10 hours of natural speech. If you're interested in knowing the finding, come to see my poster.
Next, Danyang Zhang will be presenting mobile-based dictionaries investigating Chinese EFL learners' use and the effectiveness in incidental English vocabulary learning.
Do you usually use mobile dictionary when you encounter new words? Have you ever expected you can acquire some after looking up? Results of my study show that Chinese university students, they prefer to read only definitions and pattern of speech when they use mobile dictionary. Sometimes they only read only one definition and Chinese translation if available. In comparison, the non-English major students and the bilingualist group used more than others. Mobile-based dictionary can help learner to acquire vocabulary knowledge in terms of spelling, meaning use, and pronunciation. But they forgot some without further intervention. And overall, the English major students and the monolingual group performed the best, while the non-English majors and the bilingualist group have made more progress. To conclude, there is a strong correlation between dictionary use and the vocabulary test performance. Please come to us to see my poster to know more about how to make efficient use of mobile-based dictionary in your second language vocabulary teaching and learning.
Next is Yaning Chang, who will be talking about modeling lexical decision in adults with and without acquired dyslexia and semantic dementia.
Lexical decision task is one of the most frequently used paradigms in experimental psychology, but the underlying mechanism is still unclear. So we have developed computational models of readings based on neural network modeling to investigate the mechanism underlying lexical decision in visual word recognitions. So previous model has focused only on orthography processing, but our model can flexibly integrate visual orthography, phonology, and semantic to address the lexical decision paradigms as we observe in adults with or without acquired dyslexia. So if you are interested in our poster, please to come to visit. Thank you.
Next, we have Guy Aglionby telling you about modeling polysemy in distributional semantic models.
Hi, I'm Guy, and I work on explicitly modeling word sense in natural language processing. In NLP, we tend to represent words as a list of numbers called embeddings. These embeddings have the property that semantically similar words have similar embeddings, and semantically different words have different embeddings. Representing words in this way makes it pretty easy to use them in machine learning systems. However, doing so also conflates all of the different word senses of each word into that single representation, leading to the impossible situation where the embedding for interest needs to be similar to those of charge on alone and curiosity, which should themselves be really dissimilar. To combat this, I propose a new system to create an embedding for each sense of each word using Word2Vec and getting information from WordNet, and show that this leads to performance improvements in language modeling task. Thank you.
Then we have Benedict Zolfo, who will be talking about modulating speech processing with alternating current stimulation.
It has been shown in the past that the alignment between neural oscillations and speech that we heard about in Usha Goswami's talk is enhanced if the speech is intelligible, but it remained unknown if this alignment is causally relevant for speech processing. To test this, we manipulated the phase relation between speech and neural oscillations using transcranial alternating current stimulation, or TACS. We expected an optimal phase relation between TACS and speech that you can see on the left, which is expected to lead to an improved speech comprehension and a relatively large bold response to speech measured using fMRI, and vice versa, a non-optimal phase relation that leads to an impaired speech comprehension and a relatively small bold response. Did we find that neural oscillations are causally relevant for speech comprehension and speech processing? Find out at poster number 18.
Up next, Özge Öztürk will be sharing with you her work on multilingualism, multiculturalism, and implications for health and well-being.
Hello, good afternoon. My name is Özge Öztürk. Anxiety disorders, generalized anxiety disorder, is predominantly measured by how well we can tolerate uncertainty, by how well we can deal with situations where the outcome is unpredictable. We know that multilingualism, multiculturalism, being multilingual or multicultural, provide us with various opportunities to practice tolerating uncertainty. Therefore, we asked in this project, would it be possible that multilingual, multicultural people actually can tolerate uncertain situations better and therefore score lower on the anxiety scales? Thank you. So, if you would like to know more about what we found and if we can actually propose being multilingual, multicultural as a pill against anxiety, and if you would like to participate in our research, please find us at poster 20.
We then have Danielle Saunders, who will be presenting multiple sentence representations in machine translation.
Everyone's seen computers translate or try to translate human language with varying success. Turns out machine translation works best when the proposed translations from multiple models are combined in one ensemble. But what happens when one model in the ensemble produces a different representation, like this syntax example? We know that different representations can be useful in translation. Syntax, for example, can improve sentence structure. But the representations can't be directly compared, so ensembles typically just use one representation. Our work uses a known mapping between representations, allowing us to use them in the same translation ensemble. To find out more about our approach and our findings for multiple sentence representations in translation ensembles, please see our poster.
After this, Eddie Sohoglu will be talking about neurocoding schemes for lexically driven prediction in superior temporal cortex.
An influential theory in cognitive neuroscience proposes that what listeners are doing are continually predicting the speech that they hear, and it's the difference between what's predicted and the actual inputs of the prediction errors that are used to update previous predictions. So to test this, we presented 21 listeners with spoken words varying in their predictability. And we next then used computational modeling to formally characterize how prediction errors changed across our experimental conditions. Finally, we recorded brain responses using fMRI. These are brain responses in response to the speech. If indeed listeners compute prediction errors, then the results of this fMRI analysis should resemble those of the modeling. To find out whether that's the case, come find me at my poster.
Up next, Yintang Wang will be talking about predictive neural mechanisms of spoken word recognition and learning.
Listeners recognize familiar words in their native languages with a speed and accuracy that is unmatched by the artificial system. And a mechanism that has been proposed to help achieving this is prediction. For example, if we hear the word block, the next time we hear the initial sound blah, the word block will become more accessible, which helps us predict its forthcoming. However, what if what we actually hear is another familiar word, such as blood, or a new word, blog, then there will be a mismatch between what we predicted and what we actually hear. And we call this mismatch prediction error. Currently, studies and models suggest that prediction error delays recognition of familiar words and enhances learning of new words. And we are interested in learning the role of prediction error during these two processes, and where and how the brain signals prediction error through a series of behavioral experiment and neuroimaging experiments. And please come to poster 24 to find out more. Thank you.
We then have Grace Rice, telling you about semantic memory performance after left versus right anterior temporal lobe resection.
So semantic knowledge refers to the knowledge we have for the meanings of words, and it allows us to recognize objects and people, and helps us to understand the world around us. And in my research, I'm really interested in where in the brain this knowledge is stored, and in particular whether there are any differences between what the left and the right-hand sides of the brain are doing. And one way we can address this question is to test patients who have very localized damage to either hemisphere and see how they perform on various semantic tasks. So the data I'm showing in my poster today come from patients with temporal lobe epilepsy, and they've had surgical resection of either the left or the right hand side of the brain to help alleviate their seizures. And we've given them lots of semantic tests, and we want to see how they perform on these different tasks. So for more information about the types of tests that we use or how these patients actually performed, come see me at poster 25.
After this, we have Oriana Bayraktari sharing with you about the effects of language contexts on executive function, a pilot study.
It has been extensively proposed that bilinguals have both of the languages active and suppress one to use the other. This is thought to offer them a benefit in interference suppression, which extends beyond language use. Based on the adaptive control hypothesis, we look at two interactional contexts and how they affect cognitive demands on interference suppression, and how bilinguals adapt to these cognitive demands. In our pilot study, Greek-English bilinguals performed a flanker task while listening to either a Greek or English dialogue, which is a single language condition, or a mixed Greek and English dialogue, a dual language condition. And after each dialogue, they would answer comprehension questions. Our preliminary results indicate that different language conditions had different effects on the cognitive demands for both interference suppression and dialogue comprehension. And for more information, come see poster 26.
Then we have Rocco Cho, who will be talking about the neural representation of color knowledge entails brain regions beyond the visual cortex.
So I'm going to present a series of work on a topic that has been bewildering scientists and philosophers for years. We know that many things in the world have canonical color, and color conveys information that guides our action, such as using the color of a traffic light to decide whether to put on the brake or go forward. Previous research has been focused on the visual parts of the brain because some researchers believe that knowing about color relies on the same brain area that underpins perceiving color. However, we know that some patients who have lost their color perception can still retain perfect color knowledge, whereas other patients who have impaired color knowledge can still perceive color normally. And this double dissociation means that color knowledge entails not only the visual parts of the brain. So please come to my poster. I have some information to show you.
Up next, Katie Howard will be sharing with you the school experiences of bilingual children on the autism spectrum.
Can you be bilingual if you are autistic? The answer is yes, but it's oversimplistic. So sit back and relax as I try to explain why being bilingual is good for the brain. For children with autism, the advice sometimes goes, just stick to one language and see how things go. But in fact, we are seeing that being bilingual gives children with autism a chance to mingle. When their parents communicate in two different tongues, just speaking the one is like a harmony unsung. So what is this study? I hear you all cry when I interviewed children who brought tears to my eyes as they gave their perspectives on what life is like. As an autistic bilingual, it's like riding a bike. Once you get the technique, the wheels keep on turning. Bilingualism is good for their interaction and learning. So why does this matter? The question is great. Grab some tea and come find me. I'm at poster 28.
Power clap, guys, power clap. After this, we have Rebecca Jackson telling you about her work entitled Towards a Computational Model of Controlled Semantic Cognition.
Semantic cognition is the controlled access and retrieval of multimodal conceptual knowledge. It's multimodal because you can access the same information whether you hear a meow, read the word cat, or encounter a real-life cat. And semantics is hard because you have to make a representation that's the same across all of these and the same across time. So it must ignore context. But at the same time, in any interaction you have to give contextually appropriate responses. So how does the brain do context-dependent and context-independent semantic processing within one network? We built 7 different neural network architectures to find out what architecture is capable of doing controlled semantic cognition and consider what architecture we might have to do this within the brain. To find out what building blocks you need to build a semantic network, come see poster 29.
Next, Kate Neal will be presenting her work entitled Towards Automatic Grammatical Error Detection of Non-Native Spoken Learner English.
That very long title means what we want to do is to help people for whom English isn't their first language speak better English by giving them feedback on errors they're making, specifically grammatical errors, which, as everybody knows, actually nobody really agrees what a grammatical error is in speech, which is problem number 1. But our colleagues over in computer science have done really well for this task with written English. But we've got spoken English, which has all this messy stuff in it. It's disfluent. It doesn't have punctuation, so where does one sentence start and one sentence end? What is a sentence when you speak? And if we do it automatically, we did a speech recognizer. This is state of the art. It's at 25% error for the best students. So come to my poster number, 30 and find it.
Finally, we have Anthony Lee, who will be presenting Why Are Asians Better in Mathematics? A modern investigation into linguistic relativity on number counting.
Hello, thank you for surviving this far. Have you ever wondered why some East Asians, well, some of them, are better in maths in classrooms? My poster looks at whether there's an advantage in STEM and mathematics abilities explained by a more linguistic view. In terms of that, there might be a difference between Chinese and English in terms of counting system, which explains the mathematical competence in these children in early domain-specific abilities. Like in Chinese, we come from 10 to 10, 1 to 10, 2, while in English, we come from 10 and 11, 12. So there might be a robust interaction in the counting system. And this study looks at cross-cultural aspect, and then we look at a number comparison and number estimation tasks in these children. And then It looks at whether the count transparency can account for the differences in these early domain-specific abilities. So my poster is just at the very end of the talk, so please come to it.
Well done, everyone. Thank you for being such a good sport.
So now we've got a break for refreshments and the poster exhibition, and we'll be back at 4:30.
We don't expect differences. It would be nice to test on another language. I don't see how the phonological system might adjust what we need. Well, I can tell you it's very it's very easy. We ask children to write 10 times the same words, which is an Italian word, and it was a different condition. In one condition was writing normal, bigger, smaller, bigger, lower, and it was written on a digital tablet, so we took all the parameters like duration of the writing, length of writing, so if you write bigger it will be longer, pressure, but pressure wasn't useful, so what matters is the duration, so the duration of the whole word and the duration, the relative duration of single letters, which presupposes to have a plan of what you are going to write, because when you write bigger, you have to write quicker in order to maintain the duration constant, and you have to rescale the duration of the single letter. Yeah, automatically, but not the dyslexic. The dyslexic are like your out of phase picture. In fact, looking at your picture and looking at the graph of writing, it was very similar. I mean, it's completely different. It was very similar.
But there's still time.
Yeah, of course, there is a rhythm. We call the rhythm of writing, because in order to rescale, you need to have, so to say that one letter, the first letter is 1/3 of the total duration. So it means that in one case it can be 100. So we didn't do, I don't know if this can be done with the eye or
so any movement artifact.
You have to write.
I don't need fMRI, do you? Because you've got all the predictions very clear.
Yeah.
What would be interesting is to vary in writing. So in Italy you tend to have consonant vowel, consonant vowel. But in English you might have a single syllable word that's got say 6 letters. But only 3 phonemes, or 6 letters and 6 phonemes. And that could be very interesting.
Yeah, I don't know if you are interested. We are very open
I'll
to
have
share.
a look. Yeah, my notes in this time. But I did think that was an interesting idea.
And also another thing, there's two other couple of things that I interested. One was to have a training. So we tested dyslexic children. It's just a pilot. We tested dyslexic children. A musician instructed them to drum. And for I think every day 15 minutes for 2 weeks, and then we retested them, and
So the retest was on the writing?
No, in reading.
Oh, okay,
reading.
well they should have.
Yeah.
Okay.
So with the drumming.
That's interesting.
Because I think that it's really, so not every musical activity, but rhythmic musical activity.
It should be rhythmic and ideally matched to rhythmic patterns. So I think just doing lots of music on its own won't necessarily help.
Yeah, probably associated to language. That's it.
There seems to be a number of groups in Italy starting this then, because there's a group in Milan. That's new, Antonietti.
No, this is another group, yes, it's in Cattolica, and then there is associated Maria Luisa Lorusso, with whom I work in Nostra Famiglia.
She was So there's a group in Genoa that seems to be trying to start, but they seem to have completely understanding of well, it seems to come from the woman who's been running it is Monica, but it seems to come from the multi-sensory literature of some of the and so they were finding things kind of by chance to do with time perception and dyslexia, and then they were wanting to do a whole lot of things like that. But I tried to do contact with their Instagram, but they don't seem to want to be in contact with other Italian groups, which I didn't understand what the local politics is. But shall I suggest I mean, I think the guy's good at multi-sensory stuff, but they just don't have a
the problem is that because they are out of phase, they cannot extract regularity.
I think that in the paper, so I think that being out of phase is only with one element. Well, that's the different. So that means the perception system, the whole perception system, the language is based on a slightly different structure. So that makes learning from us.
But do you think that the problem is at the level of language, not at the level of the problem?
Yes.
Yes.
It's definitely the spoken language process. And the strong data on the acoustic domain, because when I was answering that question, he was asking about dances. Certainly for the teacher, we should know that out of time and time. What's out of phase is the auditory responses and language responses.
Okay.
Of course, the governance.
So we trained children and adults with dyslexia to a very simple thing, DAAD, 500 iteration in 1 minute. After the familiarization, they were presented the same sequence but with a task. And so the sequence had randomly two sounds that sounds different from the other. On the first sound, which is called word, they didn't have to do anything. On the second sound, they had to sing. So this means that if they have internalized the rhythm, they should be able to predict when the second sound.
The one I've read.
Yeah. Okay. And both the children and the adult were delayed, so they have a reaction time. The children and the adults with typical development have a little bit in advance because they are prepared.
Yeah, anticipation. I think, so one way of thinking about the whole out of phase is about prediction.
Yeah.
Because a lot of speech
is prediction.
Yeah, and one of the things you're predicting is what is the next stress. So in that sense, anything that then involves a temporal dimension that's similar and a prediction.
So, but I think it is a problem of prediction.
Yeah.
That's one. But I wonder whether it is a problem also of extracting the regularity, because if you can't extract the regularity, you can predict, of course.
Of course.
What I found is compatible with both.
Yeah, but at the moment, I think the brain impact is also compatible.
With both?
Yes.
Because I thought that it was more compatible with saying they can't extract the regularity.
Not really, because well, anything like that is predicting. So even to know that it's a certain amount of time, you should have it.
Yeah, and so I didn't catch what they were not as good as
we matched them for improvements by so it was an adaptive task. That if you weren't very good at hearing when it was out of time, it was a very good use of out of time. If you were good at it, so overall everybody was successful so far. And the fact that
okay, so but how many were there dyslexic children?
Yeah.
Yeah. And so only those that were 70% correct.
Well, we adapted the task so that everybody was successful.
Okay.
It just meant that the delay for the big amount of time varied between children.
Okay. You get more time.
Yeah.
So, which may mean that they can extract regularity, but they need something more.
No, I think if you can't bring time, if the brain has time using it is going to be better extracted. It's not just getting regularity, but it's at one phase removed because the other bits of your brain might need time. So that means that it's like a finding it means it's not a straightforward because there are at least 3 time scales that are and maybe 4. And the way they're bound together might be because Japanese, for example,
Yeah. It doesn't work. It doesn't work either. Yeah. Yes, yeah.
I'm going down. People are too nervous.
You're not making him nervous, are you?
Oh, I'm one of the nervous ones.
Oh, no, you're not. You'll be fine.
Yes, that needs to answer your laptop. Okay, what's in?
Sorry. That. Stop it. That there. The only thing is, I don't have a clicker.
Oh, that's okay. I can use the arrow keys. Yeah.
Clickers link up those ones. It one,
No, that's fine as long as I have sort of pointer around.
no. There isn't. This is the clicker there. This is
That's good. Thank you. So let me just check. Okay. Yeah, that's perfect. Thank you. Would it be all right to leave my laptop here, or do you think I should
Well,
just...
there's a presentation for you.
Okay.
So,
Okay, I'll unplug then.
but I'll have a holding slide player, so
Okay.
when you set up the C, it'll just be a holding slide.
Yeah.
So you can plug it in, but it's not for one, because I'll just sort it out when it's ready to go.
All right. Perfect. Thank you.
Yeah, that's good. Are you happy to be flexible?
Yeah.
Yeah, that's good. Cool. Lovely stuff. I'll get this one away then. Just kind of cluttering everywhere. The desk.
was, yeah. Are you going to use your laptop?
I wasn't planning to, but I was just wanting to plug them
When you plug that, I thought it's actually an Alexa.
Okay. Are you using yours?
Yes, because I want to use the presenter mode because I've got some notes and I don't feel like I can do it without my notes.
So do I just need to shout?
I think there might be some sockets in the kind of quiet area around the corner as well. If you want to just go, just email me. I want to see your talk. That's true. I'm just going to accept it.
So is it just you and then me?
No, there's somebody else. Yeah, they've really packed it all in, haven't they? There's something about language processing. Computer science type person.
Hello. I'm the last speaker, and I just wanted to make sure that you have got my slides.
I have. Do you also want to see?
No, I'm going to wing it. Not true. I've practiced, I know it. Okay.
It's not on that yet. It's playing.
Okay.
It will be on that.
And this just, which one moves it along? The
Not that one, the yellow good one. That one, yeah. Let's bring on that. Oh, yeah.
okay.
You might find yours still in the era of universal grammar in this university.
Yeah?
Yeah. Well, some of it anyway. But
Challenge
some of them.
And that's okay. Sorry?
It's creepy twins.
Creepy twins. The other ones are my nieces, so they're a little less creepy. A long time ago now. Yeah, they are creepy twins. I saw some twins rather like that when I was doing my swim testing. Does this one have a light on it, or is this one just like it's all there. Yes, it is. What number? 2. Yes, it sounds like he's had one of those days. Oh yeah, I had some lessons a long time ago from my computer, and then just in the last few minutes I just thought I can't see carefully at all. I went to have my eyes checked this summer. It was a very quaint way of putting it, but the gist of it was, this is what happens when you get old. Thanks very much for that. Well, and he really did, because I was waiting in the waiting room sitting next to this guy who was maybe a few years old with me, had a bit of grey hair, anyway. The optometrist comes out, walks straight over to the bed and says, "Professor Wilbur, I'm going to see you." Oof. So that didn't get us off on the right foot. I said, "I think you find I'm Professor Wilbury." Ooh.
Still things in glasses on your face, hey?
So, yeah, just get
You just have to not react. I think that's the main thing. It's too tempting sometimes to just dive in, isn't it?
Yeah, no, I try not to do that anymore. Sometimes I just... There is. Sometimes it's just so ludicrous, it makes me smile. Donald Trump complaining because the French make it very hard for the US to sell wine in France. This person's like, I don't want our wine. Why would you want Californian wine? Sometimes it does make me smile because it's just too stupid. Oh man.
to me 2 years ago. Do you have spiritual mentor?
Notes should be on there for you.
Okay, that's fine.
Are you happy with that?
Yeah.
If I quickly just show you.
Yeah.
It's quite. I'm clearly not going to read all of those notes, am I? So I think it's okay. It'll be fine. Thank you. No, this way is fine. Thank you.
And I'm not the best example by any stretch of the imagination, but certainly what I've learned over the years and started to think that way, you can get your kind of ambition or vision can get lost in just supporting other people.
Yeah.
So
Do you live in Cambridge?
You do? To do what?
Psychology education. So, to do whatever comes in, wants to do.
Being tempted to go to Australia. Yeah, no, I think that's I think like 3:30 this morning, it's this was 2 months ago. Britain wasn't happening, that's never even been thinking about it. Yeah, and you kind of vacillate. So on some days, right, it's just nobody can see a real adventure and stuff, but I don't sometimes like Maria's just at that age where I can go now, she'll probably be back. And so it does feel what I do think they're strong, and much stronger on speech language literature, and they seem to find quite a few trials. Again, certainly that's what they want to translate in respiratory, but they seem to think in this country. I last week to something, but can't really see it's a bench. It is a yeah, just tell me. Yeah, just pretend that you're gonna fix it. And this is the thing that this is the thing that we're going to try to if you can't handle what's going to be beneficial, then you need to be clear about what it is that you're trying to do. But I had students yesterday presenting Black which is 12 sessions. It's 12 sessions. And she was a connecting and then I said, well, how many are you picking up? And they're all back. Like I said before, she said, this is really? She said, yeah, most kids that I said they got 3 hours. So kids with severe autism get 3 sessions of speech and language therapy. And I did say to her, why? What did you do? And I totally agree with you. I just think it would be better to just say we don't offer that service. And then people respond. And then people
vai avanti più rispetto a quello che avevamo portato, però se vuoi, se vuoi. No, io non posso rispettare un'alternativa adesso perché non so
Yeah, activity and headspace. And that's the very hard thing about making me kind of big decision.
Okay, va bene.
And I say to her, anytime I engage history, I always wonder about
perfetto, va bene. Sì, va bene, perfetto. Ok, va bene, ciao.
Yeah. Again, that's, I don't know if it's going to be as bad as that. That's kind of how I feel now. That we're all just kind of going,
So you okay to go next? Yeah. What we're going to do? She's going to take some medicine. Okay. You go next. Then, if she's not well enough, we'll just skip that and we'll go straight to the drink section.
Okay. Yeah. Sure.
Yeah.
Oh, not her. That's terrible.
Yeah.
She
well, her
ill-cured.
husband had gastroenteritis. Well, she thought he had he but she thinks maybe it's a mild topic. So. Yes, please.
Slowly.
Okay, so I think my talk's going to be 30 minutes, right? Questions. So if you give me a 5-minute warning. Can you do that? Yeah. Thank you.
What's the College Association?
They do like highest bidder. So what happens is you get if any of them would be they sort of have a post on it, which is so I just want to which position, and they said yes. So I guess if you know
It's still worth like that in this day and age.
No one sorted it out.
Yeah. I only met him the first time I
It's one in
Sorry.
So welcome back, everyone. According to the program, the next speaker was Dr. Maria Jakarta, who is with us, but she's not feeling very well. So what we're going to do is we're going to have Dr. Jenny Gibson first, and see whether we will have Maria talk to us afterwards, after Jenny's talk. Otherwise, we will have to see whether we're going to have a break before the next plenary speaker. So it is my pleasure to introduce our next speaker, Dr. Jenny Gibson, who is a lecturer in psychology and education at the Faculty of Education here at the University of Cambridge. Jenny is a principal investigator in the Center for Research on PEDO, Play in Education, Development and Learning, where she leads a team investigating the role of play in children's linguistic, social, and emotional development. She also works closely with Napoleon Katsos, who is at the linguistics section, and they co-lead the Talking Research Group, where they do cross-disciplinary research spanning education, psychology, and linguistics. Jenny is a member of the Royal College of Speech and Language Therapists, and today she's going to talk to us about the effect of early language and communication environment on social outcomes for primary school children.
Thanks, Yanthi. I'd like to start my talk by thanking my collaborators. So the research that I'm going to present today is done in collaboration with Dr. Umar Tasib from University of York and Dr. Diane Newbury from Oxford Brookes. So as a speech and language therapist, the way in which I started my research project was thinking about developmental language disorder. So developmental language disorder is when a child has problems with language development in the absence of overt causal factors and in the presence of seemingly otherwise typical development. There's a lot of hedging in there because really beyond that there's a lot of disagreement in the research literature about how to best characterize and define this condition. Some of the things that we typically see in the early years, at least, we have problems with semantics and morphology, morphosyntax. Children might have difficulties understanding the meanings of words and learning new vocabulary. They might have problems with discourse level organization, particularly as they're getting older and conversational turn taking is important. And underlying that, there might be psycholinguistic issues too. So for children who have seemingly resolved linguistic difficulties, we might still see problems in tasks like non-word repetition that are thought to tap into constructs like working memory. Children with linguistic difficulties may or may not have problems at the level of pragmatics, so using language to do things. And from a speech and language therapy point of view, a really important criterion is that there's some functional impact on everyday life. We don't want to treat people for no reason, so they've got a bit of a linguistic difficulty but it's not really impacting on anything, then of course we're not going to flag that as a problem. But my interest has really been on when there are concomitant social functioning difficulties that go with developmental language disorders. And I'm sure you know that linguistic and social development are mutually influential across the developmental span. And there are strong links from both language development and social development in predicting children's later psychosocial adjustment, so their emotional and behavioural regulation skills. Alongside this, we know that socioeconomic status is a relevant factor. So children from lower income backgrounds, from poor backgrounds, are at risk for problems in social development and linguistic development, and in turn this might impact their psychosocial adjustment. So this aim of the study that I'm going to present today was to try and understand some of the pathways from early life through to children's psychosocial adjustment at the end of the primary school age, and to compare whether there really is any difference between these pathways for children who have language difficulties and children who are developing typically. To start off with, we're really thinking about this concept of the early language and communication environment that Sue Ralston and colleagues have looked at. And this is really about how you nurture communication in the early years. So this has been conceptualized as what parents actually do with their children, so the fun activities that Usha was referring to earlier might be singing, telling rhymes, reading stories together, and what they do with the resources available to them. So these are the factors in early life that I was interested in looking at alongside socioeconomic status. Thinking about where that might take you, so you might have the early language and communication being really, environment being influential in the early years. In middle childhood, I was interested in what other factors might mediate between early skills and later psychosocial adjustments. And some of these are kind of very closely meshed together. I was interested in the impact of children's friendships, because we know that friendships provide strong support for children's later psychosocial development and can even be protective against effects of early adversity on later psychosocial outcomes. I'm interested in play and psychosocial issues around play in particular, thinking about play with peers in a social context as a useful way of children learning more about the social world. I wanted to know more about the role of language skills later on in this middle childhood period, and also their social development. So to pin these down into research questions, I was interested in what the effects of the early language and communication environment on social and linguistic development in early middle childhood would be, and whether these linguistic and social factors would then affect children's psychosocial adjustment, behavioural regulation in particular, at the end of the primary school period, and whether there is any evidence for cumulative effects or influences of these earlier factors. The way in which we approached this study was a secondary data analysis approach using the Avon Longitudinal Study of Parents and Children, LSPAC for short, and this is a birth cohort study sampling children from the west of England born between 1991 and 1992. There are around 15,000 children in this cohort, around half of them are male. And for the purposes of the current study, I was interested in the parental and self-report questionnaires and the direct measures of linguistic and social ability that are in this study. Now, longitudinal research is really good, especially when you've got a secondary data analysis cohort to use, because you don't have to collect the data yourself, which is great. And it also allows you to do something else. It allows you to travel through time. So if I identify children with linguistic difficulties that seem to be quite persistent in the 7 to 9 years bracket, I can then go back in time and look, well, what do these children look like in the earliest period of life, and then look forward to see how they do later. So I'm going to talk you through next some of the measures that we pulled out of the LSFAT cohort for this particular study. So in the early period, we had the measure of early language and communication environment that was indexed by mother-child interactions, by the child's interactions with others, and with the resources that were available for play and learning in the environment and for activities like going to the library. Socioeconomic status as a composite measure, looking at occupation and income levels, and also there's also parental checklists looking at receptive and expressive language, age 15 and 24 months. In the early middle childhood period, so around 7 years old, there were some direct assessments of language ability. It's quite good for a cohort study to have this level of detail. So it had a picture naming task, a discourse comprehension measure, and a non-word repetition task. And it also had parental reports of those things that I was interested in as potential mediators, the friendships, the play behaviours, particularly social play behaviours like playing games and taking turns in games, general prosociality, and also Dorothy Bishop's children's communication checklist was in there too. Finally, the outcome measure at age 11 years was the Strengths and Difficulties questionnaire, particularly looking at these behavioural difficulties composites. So the peer problems, hyperactivity, and conduct problems scales. So these are parent ratings of their child's adjustments for these issues. So the sample that we selected from the LSFAT cohort were selected on measures age 7 years. And children had to meet two of the following criteria. So they had to be low on pragmatics, non-word repetition, receptive language, or have scored positive for receiving speech and language therapy. The reason we did these four is that, of course, we can't do a clinical assessment for developmental language disorder, so we're trying to use a proxy for language difficulties, but of course this won't be exactly the same as a clinically identified sample. Once we've done that, so the impressive LSFAT cohort study sort of reduces because we haven't got direct measures on that whole sample of 15,000. We identified 394 children with linguistic difficulties, and then we selected a matching sample based on age, socioeconomic status, and gender. So here we have a table just showing some of the differences between these two groups on the main study measures. And just highlighting here, we've got t-tests comparing the differences. What we see is that children with language difficulties identified in the middle childhood years, when we look back, we see that they had slightly poorer scores for early language and communication environment for everything except the measure of resource. Similarly, for our middle childhood measures, you can ignore the bottom of the table because they were the selection measures, so it's not surprising that the children were worse off on those ones. But when we look back to the early parental checklists, again, on average, this group that we'd selected based on middle childhood characteristics had poorer receptive and expressive vocabulary and grammar on these early measures. In terms of the social mediators that we were interested in, there was only a significant difference in play skills out of the three that we'd picked out for testing, with the language difficulties groups having a slightly poorer score. And finally, on the outcome measures, and this is something that we've seen in different studies, not just this one, children with language difficulties identified in the middle childhood period were worse off in terms of their emotional and behavioural regulation. Okay, So the approach that we took to analysing the data was a structural equation modelling approach. And we did this in N+, and we compared the language difficulty group to the no language difficulty group using the grouping command. We have reported the model fit indices, but we didn't tweak them because we were testing a theoretical model. We weren't trying to fit the model to the data, so it is what it is. And this is what we were testing in theory. So in case you're not used to looking at these types of diagrams, in the ellipses we've got latent variables, and the ones that kind of feed into the ellipses are the observed variables. And we're going from left to right across time. So we've got early language communication environments, and SES are measured at 0 to 24 months. The mediating variables, or the middle part of the pathway, is the 7 to 9 years old band. And at the far end, we've got the psychosocial outcomes at 11 years. And the kind of arrows that are pointing from left to right across the model are the relationships that we hypothesized would be in the model. So let's see what happened. So for the typically developing sample, I've highlighted the paths that were significant in this model in blue. I haven't put the weights on because it just got too confusing as to present as a visual. But essentially we can see that socioeconomic status is quite influential on these measures across time. So we've got direct pathways from SES to psychosocial adversity and to these social outcomes in the centre. We also have an indirect path via play. So children who had better early language and communication environments in a typically developing sample had better play skills, which in turn was negatively associated with psychosocial adversity. Now for the language difficulties group. Again, we're seeing a very similar picture. So we're seeing similar effects of SES directly impacting on psychosocial adversity later on, and SES and early language environment impacting on language, play and prosociality in the middle childhood period. For the language difficulties indirect paths, we see again a very similar picture with the addition of an extra indirect path via prosociality. So there's a sort of cumulative effect from early language environment through prosociality that's protecting against psychosocial adversity. So to quickly summarize, the early language and communication environment promotes positive friendship, play, and prosociality in early middle childhood for both groups. And there was no direct pathway from early language and communication environment through to the psychosocial outcomes at age 11. It seems that socioeconomic status is pretty significant. It directly influences paths from language through play, prosociality and psychosocial outcomes in typically developing children. And the pathways are broadly similar whether you've got linguistic difficulties or not, according to our measure. For both groups, there was this indirect path via play. And for the language group, as I said, there was also an indirect path via prosociality. In general, children with language difficulties in middle childhood tended to have a poorer early language and communication environment. And I wondered if that was a within-child effect, that perhaps parents might find it hard to provide an adaptive environment in the case that the child has early linguistic difficulties. I was also quite surprised by the lack of friendship effects. It was something that we'd found in other studies, and we thought that that might be protective against psychosocial adversity. Possibly this was a measurement problem. We were measuring in this study friendship quantity rather than quality. So it could be things like intimacy and conversational factors are much more important in friendship than just how many friends you have. I think the consistency of the play effect of both samples was interesting because it suggests potentially an interesting target for teaching or scaffolding conversational and linguistic interventions around if necessary. It's quite easy to think about that being motivating for children. But what I think think is interesting is that when the early language and communication environment was optimized in this study, children with language difficulties benefited the most, so they tended to get the most protective effect out of it. And I felt that this broadly similar, this in conjunction with the broadly similar effects of early language and communication environments across the two groups suggests that that's the best place to be targeting intervention, maybe with something tailored for those with evidence of early linguistic difficulties. So where are we going to take the research from here on? Well, we want to have a closer look at the language of friendship and play in the middle childhood period. We didn't see direct effects of language on psychosocial outcomes, which is, it's a good thing. But I think for those children that are struggling, it looks like targeting social language could be particularly interesting. Thinking about the early language environment, I think this supports a resilience perspective. Not all of the children in the language difficulty samples went on to have problems, and I think that if we know that they can benefit more from that early language inputs, then maybe that's where we should be targeting it. Finally, I think using the ALSPAC data, we can also look at academic outcomes, and that will be the next stage of our study. So thank you for listening. These are the acknowledgements that I'd like to make, and let's take any questions. Thank you.
Hi Jenny, that's really lovely data. One of the things they've shown in very early interactions is that something like 75% of the time, once you can crawl or even start toddling, you pick up an object and you take it to your mother or whoever's looking after you, and they talk about it. Do you have any insight into whether that's a child-driven effect in your data, that these children in these lower socioeconomic families aren't doing that, or that the mothers aren't responding to it? Because they could both be places to intervene.
Yeah, I think that's really interesting, and I think what we need now is really rich observational data. From this kind of study, you can figure out what to look at. It's quite macroscopic, and then I think once you've got a bit of a clue, then you can hone in and see how these things are unfolding in real time. But I don't think, as far as I know, that they've actually got video data from these ages. So yeah, it'd be a great study too.
And the idea of play as an intervention, the earlier you start could be better.
Yeah, absolutely.
That was really interesting. So one of the things that you suggested was that the early years are a good target for intervention. But you obviously need to be able to use some sort of measure in those early years to distinguish those that require an intervention from those that don't. Your reliable effects, so looking back from the 7-year-old assessment to kind of 18 months, I think are very interesting. But getting a reliable effect in a t-test is not the same as showing that you've got some predictive value from those early assessments. Do you have any ideas about what you could use to assess early language that might distinguish those that are going to go on to have problems?
Well, if I did, I think I'd be making a lot of money. It's one of the sticking problems in this kind of research. We do see a lot of variability in early years language, and not a lot of reliable indicators about those who will go on to have the most persistent problems. But I'm sure Courtney's data will be able to shed some more light on this.
Thank you.
Thank you, Jenny. So there was some recent research about the importance of the back and forth communication in the early language environment, and I'm wondering, because it's so interesting that's more predictive than the amount of language that's heard. And I'm wondering if that's a focus.
I'm not sure what I'm doing. I'm wondering if that's a focus for intervention, or if there are any measures that really look at that back and forth interaction in the whole environment that could be useful and predictive.
Yeah, so there are, and I think it's really interesting that it's attunement and turn taken has been shown to be more associated with later linguistic developments than actual quantity of language input. I'm hoping to look at this in, so we've got some really nice observational data from the CHIRP study in the Peddle Centre, looking at conversational interactions between children and a peer. So I'd like to look at whether conversational attunement and reciprocity is relevant in that age group. I don't have data for a younger age group, but I'm sure there's some interesting things out there that people are working on.
I think I can speak loudly and that would be better possible. Thank you, Jenny. That was very interesting. I want to just ask if you have any insights for the role of language delay or language difficulty more broadly speaking in terms of psychosocial outcomes, because these are a particular type of population that seem to predominantly have language difficulty without, as you said, seemingly anything else being a challenge. But a lot of developmental disorders come with a language difficulty, not necessarily as a primary presentation, but a secondary presentation. In autism, in ADHD, we might see language difficulties. Do you have some thoughts about what the role of language difficulties as a secondary issue might be in terms of psychosocial outcomes? For example, something in autism might have an additive effect there. I don't know if my question kind of makes sense.
Yeah, it does. I think it's a complicated question to answer, but I think there's definitely some evidence that it can be complicating. So particularly when you look at the evidence of language delay in individuals with autism spectrum conditions, then you tend to get poorer outcomes. And I think one possible driver of that is that language helps you to do things. So it helps you to think about and regulate your emotions. It helps you to negotiate, to ask for help, to make a narrative and make sense of an experience. So I think if you don't have that tool to access the social world in the most optimal way, then yeah, it can be a compounding factor.
Time for one final question.
I'm a speech specialist as well, and something we were talking about in the poster presentation is that sometimes, counterintuitively, children with disabilities that come from lower socioeconomic backgrounds sometimes don't have the same modeling and cotton-walling effect that sometimes prevents them from making friendships. So we've seen in our practice that when children hear use other ways to talk because they can't talk verbally, that sometimes the children from the lower socioeconomic backgrounds have more resilience because they've been exposed to more different people and kind of let get on with it and develop independence, compared to some of the children from maybe some of the higher socioeconomic backgrounds where parents have felt that they need to protect their children from the world and don't give them the same opportunities to engage. So just wondering whether any of those things might factor into the lack of evidence for friendships that came up in the news.
That's a good question. So I guess the way that I'd kind of interpreted the lack of a friendship effect was in two ways. So possibly that the measure wasn't very good, so it was just counting number of friends rather than the quality of the friendships. I also wondered how much parents really knew about their children's relationships and whether actually self-report might have been a better mechanism at getting at friendship quality. You made some really interesting points about resilience and kind of letting children be independent and discover and make their own mistakes, make their own friends indeed. But I don't have any evidence directly speaking to that question at the moment, but I think it's a really interesting one.
Thank you very much.
So, I'm delighted to see Dr. Maria Yacata walking down the steps. Means that she feels better. So, our next speaker is Maria Yacata. She's Associate Professor in Natural Language Processing at the University of Warwick. She's a fellow at the Alan Turing Institute, where she co-leads the Natural Language Processing and Data Science for Mental Health Interest Groups. Today she'll be speaking on using NLP and heterogeneous user-generated content to sense mental well-being. And I think the chair Okay.
I'm a bit of an invalid, but hopefully I'll go through the presentation.
Okay, well, thank you very much for being patient, everyone, and for inviting me to give this talk. And hopefully it will all go smoothly, and some interesting questions. So yes, thank you very much for the introduction. The slides don't seem to appear in front of me. Should that be the case? So anyway, I like putting up this slide when I'm talking to quite an interdisciplinary background. And so this is my sort of quick description of natural language processing. So many of you here will work in this area, but some of you are not so familiar. So it's a field that tries to give a structure to human language and for resolving different kinds of tasks, and also give us intuitions about cognition and how and human language. I'm particularly interested in biomedical applications that have some innovative element with respect to NLP methodology. And very importantly, our field has an overlap with machine learning, but it's not only about machine learning or just about deep learning, and there's clearly an overlap with there's a really important aspect of it, which is the main questions. So I like this quote by Chris Manning on it's not about the latest state-of-the-art method, but the problem definitions. The problems will not go away, and let me say a little bit more about user-generated content, because as Yanti said, so my talk today will be about using NLP and heterogeneous user-generated content to sense mental well-being. So what we mean by user-generated content is the plethora of different kinds of digital content that we create as we go about in our everyday lives. So these can be social media posts, texts, images, video, and location information, as well as data from other devices such as mobile phones, Fitbits, and all of this kind of digital content contains a lot of interesting behavioral cues. So I will present work involving linguistic and heterogeneous data to develop automated methods for sensing of mental health. So why is it a good idea to use language as a sensor for mental health? Well, a lot of mental health conditions are very poorly understood, so they're not just about the genetics of the condition. We increasingly, the clinical community wants to look at new and better diagnostic measures. They're very interested in longitudinal phenotyping, so basically trying to create the phenotype, so the fingerprint of a condition, both using clinical data over time, but also behavioral data. And obviously language forms a large part of this behavioral data. So what can we do so far with NLP for mental health? We are quite good at automatically identifying sentiment and emotions in text. So this we've been doing for for a while now, and when I say a while, it's a new field, so I would say the last 10 years we've been doing this quite well, or increasingly well. We can distinguish individuals who have a mental health condition versus healthy controls. So being able to say, take someone's post on social media and say this person has depression, this person has PTSD, this person doesn't seem to have a condition. And we're also working on personalizing classifiers for emotion and sentiment. So one of the issues is if you create a way of determining emotions for these have been trained on one population, how do we make sure that this can transfer well to different individuals? So that's something we are working more on. So what has been done in terms of using textual user-generated content for mental health? So I'd say there's a large there's two main approaches. One is characterizing, making predictions at the postal level, so seeing a particular post and saying, this post is showing that someone has depression, or this is a happy post, or make predictions at the user level. Is this me doing something? All predictions at the user level, where you have a bunch of posts that an individual has written over time, and you use this information to decide on whether the individual has a certain condition. And longitudinal data, so data that has been produced over time, so posts over several months, have been used, but they have not been used for longitudinal predictions. So what is not being done at the moment is to be able to say at a particular point in time, given your posts so far, or yesterday's posts, how you're going to be tomorrow, or how you are today. So that's something we want to do. Is it better now? Okay, so I'm probably a bit subdued, so I will try and pick up. Ours is the first piece of work on combining textual data with mobile phone data. So the majority of the work is on textual data. And there's work from a different community, which is smartphone data studies, so mobile phone data studies on mental health. And there the idea is to use sensor information or location information, so things like GPS data and accelerometer information, to be able to find, to say something about the individuals. So there's been the well-known student life studies, which have been looking at the correlation between phone sensor data and GPA scores. And there we have quite it's longitudinal, but it's quite coarse temporal granularity, and there's no text involved. And then there's mobility patterns based on GPS data, and this has been shown to correlate with depression. Again, there's no text data, and there's quite a coarse temporal granularity. And then the third study as well that I mentioned here is combining a wealth of mobile phone data, but again, no textual data. So we've we created a data set that includes both sensor and phone usage data over time. And we wanted to calibrate this against automated, to use this to train automated mood predictors and calibrate these against well-established psychological scales. So that was the goal of this study, which we did together with the Center for Urban Science and Progress at NYU. So we had data from 30 students and each student participated in this study for 4 months. They allowed us access to SMS messages, mobile phone use, sensor information, so everything that we could get from their phones. This was only Android phones, by the way. And also we had access to their SMS messages and social media posts, as well as messages that had been written on services like Facebook and Twitter. And so this is very quickly sort of kind of a quick indication of the kind of data we have. So here we have a combination of textual features and mobile phone features. So our textual features included word embeddings, topics, lexica, numbers of different types of posts and n-grams, so quite coarse linguistic features as a first step, as well as things like Wi-Fi, that a person is connecting to, locations, calls, and usage statistics. Now, one of the issues of such a data set is that you have a lot of missing data. So in the first analysis that we did, we actually decided to aggregate for a missing feature, aggregate values of a feature if we had values for that feature within 6 hours of the completion of a mood form. And where we didn't have values for over 6 hours, these instances were actually excluded from the analysis. Now, I'll get back to the point about missing data and how to deal with this this important problem. So the task here was to use the textual data and the mobile phone data and then predict at different points in time mental well-being scores. And this was published a couple of years ago at Coling, and the approach that we took was to model each type of source. So there's a question here of how you want to treat your different sources, whether you pretend that everything is the same and you put it all together in one matrix, or you want there to be a different handling of the mobile phone data and the textual data. And in this case, we used multiple kernel learning with SVR. And what that assumes is that you have a different kernel for each type of feature. So, and then you find, you basically weight your, you learn weights for your different kernels. And while this performed, it was a promising performance in the sense that we were able, in an agnostic five-fold consolidation, to get good values. The issue is, how do we actually deploy this in the real world? So can we actually use this type of model to with unseen users? So that's one big question. And the big benefit of the multiple kernel learning is that it actually does try and use all of the features. So if you see the red and the blue here, we have the random forest versus the multiple kernel learning. The big difference you see here is that there's more spread of the weights across different kinds of features. So a big problem in this context is dealing with missing data and how best to do data fusion. So a next step would be to actually see if we can learn representations of these data that can give us behavioral cues both from the text and from the mobile phone data, and learn representations that are actually robust to missing data. So for example, if someone has had their mobile phone switched off and we haven't had any GPS signal, for a day, we want basically to still have a representation for that user based on the rest of the features. So we want robust representations to missing data and a good way of fusing these different kinds of features together to create one behavioral representation. So first thing that we've done. So the first thing that we did was to train so-called behavioral embeddings. So in a similar way to training word vectors, where you want to learn embedding representations, so lower dimensional dense representations from one-hot vectors, we assumed rather than having sentences and a particular word with all the possible contexts, there we are pairing a feature with all the other all the other possible features you can have for a particular instance. So for example, if you have someone being in their so every hour you get a user representation which involves where they've spent most of their time, so that would be their location. Locations are represented by the top 10 locations for each user. So you'd have I don't know, location 5 and Wi-Fi 3 and different in which user and various other features of indicative of the mobile phone use. And so these kind of construct our sentence, so to speak. So in this case, we have much fewer negative examples than you would have with your normal word-to-vec training of embeddings. And what we found is we do have some meaningful embeddings created. They seem meaningful because they, when plotted, they seem to cluster together. And there's the next step is to actually use them in order to, instead of our other feature representations. However, there still remain several questions, and I think I would like these to be some of the take-home messages from this presentation. So the data representation for this is a big challenge. So what is the best way to learn behavioral embeddings from both language and heterogeneous and multimodal data? And what I mean by multimodal data is speech, images, wearables, mobile phone usage, sensors, and then also things like health records, network, and user demographics. So it's not clear yet what the best way is to learn such embeddings. So following a word-fake-like approach is one possibility. It's also not clear whether they should be learned separately and then combined. Perhaps one may guide the other, so one can assume that the textual representations could be semantically a lot more informative than the much more dense representations coming from the sensors. There's also the question of how dynamic these representations need to be, and whether they need to encode sequential and temporal information, and do we need to focus on learning embeddings from small data, or does it make sense to actually synthesize data to address sparsity and privacy issues? So all of these are a wealth of research questions for the future in this field. And then comes the issue of the task. So should it be a prediction task? So is this trying to predict the mood score on a daily basis the best thing that we can do? Should we instead be trying to look at similarities between users over time? And also, when we're talking about these multimodal representations, it's not clear how similarity is going to be defined. I mean, maybe it's going to be Euclidean distance, or but if we have these vectors like we have with word-vec. And very importantly, what are clinically meaningful quantities to measure? So I think I'm slightly behind time, right? How much time do I have? A minute. Okay, so I'll go very quickly. So we've got a project on using language to assist with dementia diagnosis and monitoring. And again, the idea here is to collect data over time. This is the fancy tablet app that we've created to gather this data from people with dementia and their carers. We've already collected 1/6 of our final data on this, and this involves spoken dialogue, written and typed entries. And we have some further funding with Dennis Chan and Cecilia Moscola from Cambridge to look at the connection between communication, language, spatial awareness and sleep monitoring for dementia. So the last thing I wanted to talk about, or at least mention, is the validation challenges for real-world deployment of longitudinal modeling for mental health. And this doesn't just apply to language, it applies for any machine learning methodology actually in this space. And there's 3 big problems at the moment. You can read more about these in our ECML paper from this year. So the problems are one, training on past values of the target variable. So for example, if my target is mood scores, what a lot of work does is look at my previous mood scores and try to predict my next mood score. So not even taking into account user-generated content or any other features. And obviously, one problem in that is replicability, and you may not have these kinds of mood scores, but you could also have instances overlapping, so having instances in overlapping time that may correlate with each other. That's one problem. Another problem is the cross-validation. So, and this is something to be aware of in general. So our traditional 5-fold, 9-fold cross-validation here really leads to over-optimistic results, where you're likely, if you look at this figure 1, most of your mood scores in this case would fall, for a particular user, would fall within the same space. So you really are often in the danger of predicting the user rather than the mood score. So you have to make sure that you have a leave one user out cross-validation scenario. And then there's also the issue of inferring test set labels in the case of a leave one instance cross-validation. So, so all of these are things to bear in mind. So in addition to challenges in the representation, the task, one should also bear in mind the appropriate evaluation scenario. So we need models robust to different types of cross-validation, models that adapt with a small amount of training instances, and also look at evaluation methods with a clear clinical significance. So thank you very much, and sorry for overrunning and for everything else that has gone wrong.
Yeah, thank you very much. That's very interesting research. I was thinking if you have thought about the potential or possible causal relationship between the features you used and the targets of the predictions. Because to me, the features you use and the targets seems to be correlational to have correlational relationships instead of causal. I was wondering if you have any potential theories before you chose these, when you were choosing these features for predicting the targets. And after building the models, did you look at which features had higher predictive values?
So before building the models, we looked at correlation coefficients between the mood scores and different features. So we did want to include features that looked like they were meaningful. So I think one of the issues is how you deal with a very noisy mobile phone use data. So with the text, it's less of a problem because it's quite sparse and you want to use everything you have. What is more of a problem is how you deal with the mobile phone data and how you also align this with the textual data. So with the mobile phone data, we did go for things like the sensors and the GPS information and the Wi-Fi and things that seemed to be informative in previous studies that had shown that there was a relation between movement and people's locations. Yeah, sorry.
More questions?
I wonder if you could say a bit more about the linguistic features that you used in helping to compile these mental health scores. I'm not clear whether it was based on lexical items or parsing or just one or two examples would be interesting.
For this first study, we didn't use any parsing, so it was a combination of it was mainly word embeddings and lexical features, but we do plan to look at more complex things definitely in our dementia study.
Give us one example.
We want to look at lexical coherence and topic coherence over time, and that's a lot more appropriate for the dementia data than it is with the healthy student cohort that we had. So the focus of the student cohort was more the fusion of the different data modalities, and now we want to look more also at more complex linguistic features.
Thank you. I think I'm right in saying from one of your slides that for your research you were incentivizing people to volunteer by giving them Amazon vouchers. If you get to the stage where this can be deployed in the real world, can you think of an ethical way that it could be done in without people opting in? Because in a sense that could be the power of this approach, that it could be applied throughout a population. Or do you think it could only be done through opt-in?
I think one has to give people the really good motive for participating in such research, and I think one of the ways of phrasing it in a way that people won't have issue with ethics is that no one else, that actually the processing can be done on their devices. And that's something that I'm hoping to work in the context of one of the dementia projects with Cambridge colleagues. So, because otherwise, yes, there are various issues of sharing all these different kinds of data and then going all around the place on different servers. So yes, probably on device.
Take a final question.
Thanks for your talk. I was just wondering, if you've got mental health issues at the moment, you've sort of just got well-being. If you've got someone who's manic versus someone who's depressive, presumably they've got quite different patterns. One's not moving and staying in, and the other's probably going all over the place and posting lots and lots. Are you seeing that in your data? Are you seeing different sort of modes for different mental health conditions, as it were?
So we didn't see this particular study because these were students who did not have a particular condition, but we are working with people who have bipolar. So we're hoping to see more differences in that case. Yeah.
Is this a very short question? Okay.
Well, thank you for all your information. I'm wondering, well, I'm aware that it's not necessary, right? I'm aware that in natural language processing you need lots of data, but at the same time, if you combine, you fuse so many different text types like Twitter, Facebook, telephone conversations, but you produce a fantastic corpus, but at the same time, different types of text. In different types of text, you produce meaning differently. So emotion, in the case of Twitter, is quite different from the type of emotion that you produce in a telephone conversation or on your WhatsApp or messages of different kinds. So have you noticed that these different genres may have some impact on your findings in terms of emotion or opinion, because you were doing sentiment analysis as well, right?
Thank you. It's not exactly sentiment analysis. It's sort of these mood detection. But yes, I mean, people use these media differently. So some people will probably use the personal messages for more openly to describe how they're feeling, and Facebook. Some people use Facebook for their more intimate relations, and tweet for the more public-facing ones. And we hope that we don't have to engineer that into our models, but that's something that we could find, that kind of the different weighting of these will illustrate how useful the different sources are for a particular problem. Maybe for the mood scoring, the personal messages are more important than the Twitter posts, for example. But we don't want to necessarily bias the system in making that choice.
At this point, I think we should thank our speaker.
and it's a great pleasure to introduce Professor Courtney Norbury. Courtney is a fellow of the Royal College of Speech and Language Therapists and the former joint editor of the Journal of Child Psychology and Psychiatry. She's Professor of Developmental Disorders of Language and Communication at University College London, where she directs the Literacy, Language and Communication Lab. She's also a founding member of the campaign Raising Awareness of Developmental Language Disorder. Courtney is extremely well known for her work on autism and SLI. And we are delighted to have her here. She's going to speak on stability and change in child language. Courtney, thank you so much.
Thank you very much. Thank you for the kind invitation to be in beautiful Cambridge today, and thanks to all of you for staying until 5:30 to hear me talk. I was just thinking it would be nice if I'd thrown some rhyming couplets into my lecture, but I haven't really managed to be quite that creative. But anyway, hopefully it will all go well. So I am going to talk about stability and change in language disorder, and this has been quite a long journey for me. There we go. And it's quite a huge project that I'm going to tell you about. So I want to start with the thank yous. So across the top row are my wonderful collaborators. I've been very fortunate to work in a multidisciplinary team. So Gillian Baird is a consultant pediatrician, Tony Charman is a clinical psychologist, Emily Simonoff is a psychiatrist, Andrew Pickles, I always say, is the world's best statistician. George works with him on the statistics, and Debbie Gooch and Sarah Griffiths are the postdocs who really make the whole project run on a day-to-day basis. And I've been very fortunate to have these wonderful teams working with us and collecting all the data. So I'm extremely grateful to them. You will see that the project that I'm going to talk to you about involves over 180 schools in Surrey. There's no way we could have done that without huge support from Surrey. And these two women, Virginia and Jennifer, really convinced Surrey County Council to back our project, and so I'm eternally grateful to them. They've both retired now, that's how long we've been doing it. And Cheryl, Catherine and Barbara have really picked up the challenge and are helping us. We've been funded in the first instance by Wellcome. Our current grant is through the ESRC, and we've had some funding from the British Academy as well. And the schools have just been brilliant, so thanks to all of them. Right, so I started off as a speech and language therapist. I then did my PhD in experimental psychology, and I'm now chair of governors at a primary partnership in Richmond, in the borough of Richmond. So I tried to look at language disorder from many different perspectives. And one of the things that I've learned in doing this project is really to think about what the goal of specialist input is. So as a speech and language therapist, you're providing a specialist input, and the goal traditionally has been to move children from a place where they are significantly below that of their peers into this normal range. And in order to do that, you really need to get children to make greater than expected progress. Something as a school governor you hear all the time. We need children to make greater than expected progress. And actually what this study has led me to do is question whether that is possible to do, whether it's contingent on other developmental factors, and whether actually it's the best metric of success, particularly for children that I see who have quite substantial language disorders. So I'm going to try and get you all to be interested in those same questions by the end of my talk. Okay, so what I'm going to do is just give you a little bit of an update on developmental language disorders. Jenny set the scene perfectly, thank you very much. Then I'm going to tell you about SCALES, which is population study of developmental language disorder. And basically we're going to come down to this question. I think you can change language, but can you change the rate at which children acquire language? And if not, then what are the implications for intervention, but also for our kind of theoretical understanding of what's going on? Okay, so
DLD language disorder in DSM-5 was defined in this way. So we're interested in children whose language abilities are below what we would expect for their given age. And these language deficits are not explained by other things. So a whole list of exclusion criteria, a tricky one because we know that language disorder is associated with all of those things. But in this case, we're trying to use these exclusion criteria. And there's an expectation that language deficits interfere with everyday life at home or at school, so some kind of functional impact. And the bits that I put in red are the bits where Jenny alluded to this issue that we've had very little consensus in the field for quite some time. So I had the pleasure of doing my PhD with Dorothy Bishop, and we, together with some other colleagues, founded RADLD, and one of the things that we wanted to do as part of our campaign to raise awareness is get some traction on these issues where there were no agreement. So Dorothy really spearheaded the Catalyze Consortium, which is a multidisciplinary effort to get consensus both on diagnostic criteria but also on the mess that was terminology for these problems. So we did a Delphi exercise. It was international but limited to English language speaking countries because of the features of developmental language disorder, which may well be language specific. But it included speech and language therapists, psychologists, charities that represent parents, educators, etc., etc. And we did manage to get some agreement on core diagnostic criteria, and we did get consensus on terminology. And I think two of the biggest and probably most controversial things that were decided was that we would replace the term specific language impairment with the term developmental language disorder, or DLD, and that nonverbal cognitive abilities would not be used in the diagnostic criteria to exclude children from a diagnosis or indeed to limit access to clinical services. So this is why we did that. So specific language impairment, the consensus was this is a bit of a misleading term. It came about in the 1980s when people were very heavily thinking about universal grammar. And the idea, this is the closest I ever get to showing images of the brain, but the idea was that there were special regions of the brain that were dedicated to processing aspects of language, and that these were modular, so they could be selectively impaired. I think we've learned quite a lot about how the brain develops, and this kind of modular view of early brain development doesn't really hold water anymore. This seems to be the outcome of years and years of learning and exposure to language. But because of this view, as Jenny said, we kind of had this view of language disorder as being the case where language is impaired and everything else is fine. And this kind of took hold in clinical and educational services as, well, if your language impairment is in line with other cognitive skills, then that's somehow different to the situation where you have verbal and nonverbal discrepancies. And a corollary of that was a persistent view that if children had low nonverbal abilities as well as language disorders, then they can't learn as fast and they don't respond to intervention, so there's really nothing we can do for them. And that's been a problem and a challenge for us, because then what happened was that people looked to see who was getting access to specialist clinical services, and what they found was that nonverbal ability was the single most common reason that children were refused access. So even if their language disorder was as severe, if your nonverbal skills were down, you didn't get that specialist input. You just went back into the mainstream system where intervention support has been patchy at best. And yet there's been plenty of longitudinal studies that have demonstrated that more global nonverbal abilities are a key risk factor for persistent and severe language disorders. When you then look at the longitudinal data and you look at how we measure nonverbal ability, you see that this is a really untenable position. So these data come from a population study in Australia, where they're plotting here standard scores on a nonverbal IQ test and they're plotting standard scores on a language test. And these red lines are the cutoffs that people use. So in this study, they used a cutoff for language disorder at a standard score of 81, which is about 1.25 standard deviations below the mean. And the cutoff for nonverbal IQ was 85. So essentially, the children in blue would be your children with specific language impairment. They would get a diagnosis, they would get access to the specialist provision. The children in green had similar levels of language difficulty, but because they fell below this cutoff, then they wouldn't qualify for either the diagnosis or the specialist provision. And the point of this slide is to show you that actually it's a continuous distribution, it's a fairly moderate correlation. These cutoff lines are completely arbitrary, so we could just as easily do that and put our cutoffs here, so a more severe language cut and a more severe nonverbal IQ cutoff, and then that would make all of these children eligible. And somehow we're saying that these guys are different from these guys. And there's no real evidence that that is the case, either biological evidence or evidence in terms of their ability to respond to targeted treatment. So really, instead of using this as an exclusion criteria, we could consider functional impact. And we could also think about how improving language scores could drive other kinds of learning. So here's how we typically evaluate kids' nonverbal IQ scores. Since it's 5:30, I'll just ask you to do this task for me. So here we have a puzzle with a piece missing. One of these pieces fits in this spot and completes the puzzle. Which one do you think it is? Four. Well done. You're still awake. That's good news for me. Yes, now you're older and you are socialized in a way that makes thinking out loud in this kind of context a bit weird, so you're all very quiet. But if you think for a moment about how you got to that answer, what sorts of things were going on in your mind? Does anybody want to volunteer what they were thinking about?
Spatial relations number.
Number, yeah. Matt?
Comparing between the
yes.
differential comparisons.
Yes.
Work and memory, the results.
Anybody thinking things like flying or wings or sitting? Yeah. That's all language. And you were using language because language is a fantastic problem-solving tool. And so in longitudinal studies, what you tend to find is that children with language disorders, their standard scores on tests like this decline, not because they're using skills, but because they don't have access to a problem-solving tool that their peers have. So that is why we decided not to include nonverbal ability in our diagnostic criteria. I just want to say one other thing about what we know about developmental language disorder, and that is that there are genetic influences on language development and disorder. So we've known that for quite a long time, that language disorders tend to run in families, but of course families share environments as well as genes. So a better test is twin studies. My first job with Dorothy was to do twin studies, driving all over the UK, testing twins. I definitely tested a few that looked like that. These are my lovely nieces. So what you're doing in a twin study is you're comparing monozygotic twins who are genetically identical with dizygotic twins who share genes like other brother and sister relationships. We obviously are using all same-sex twins. And what you find is that monozygotic twins are much more similar in terms of their language traits. So this gives a good indication that genetic influences are important for a language disorder. And Diane Newbury does an awful lot of work trying to figure out exactly which genes those are. What this means is that we need to be mindful that what looks like an environmental influence, for example, social disadvantage, may well reflect genetic vulnerability as well. So we often like to think about this model. This is a slide from Dorothy Bishop, that it's parent talk that is a causal factor in child language. So parents who aren't talking so much, that must be the reason that their children have language disorders. Anytime we have anything in the press, that's what all the comments say, just lazy, rubbish parents who don't talk to their kids. But actually, what science tells us is that it could look like this. So it could be that you have a child who has a genetic vulnerability to have a language disorder. They're not talking that much, they're not responding that much, they're not that easy to talk to, and that might be influencing both parent talk, and indeed it does influence child language at a later point in time. But it also could be that whatever is causing the child to have problems with language influences parent talk as well. So it's not just the case that the association with SES, which we see in our study as well, is about parents talking to their children. It's probably a lot more complex than that. And of course, what the genes are doing is affecting the way that the brain develops. And these, as far as we can tell so far, are very subtle and probabilistic changes that just make learning language that much more challenging. Okay, so that was a little bit about what developmental language disorder is, or what we've agreed it to be. When Catalyze was going on, we'd started the SCALES study. SCALES is in Surrey Communication and Language and Education Study. Most of you will know that Surrey is kind of south and west of London. It's a huge borough. It takes about an hour and a half to drive across Surrey on a good day. All these little dots are schools that are taking part. If you know anything about Surrey, you will also know that it's a relatively affluent area of Britain. We did that on purpose, partly because they wanted to work with us, so that was good. But also, we know that there's an association between disadvantage and child language disorder. We wanted to know what was the prevalence of language disorder when you didn't have these massive social factors. We were kind of hopeful that by demonstrating that language disorders happen in a place like Surrey, the government might be interested. They've been a bit distracted. We continue, but we'll see. Okay, so when we set up SCALES, the idea was really to say, if a child has language disorders when they start school, what other developmental challenges are present from the start? So really interested in comorbidity, and I think the first time we wrote the grant, it was called, Is There Any Such Thing as Specific Language Impairment? That one didn't get funded, but this one did. So really it was to test this idea of comorbidity, and then it's a longitudinal study, so we can say, how do those language disorders and other developmental challenges change over time, and what is the impact of language disorder on children's educational experiences? So what we did was we bought teachers out of teaching for a day in reception. I don't know how much you know about the English school system, but at the end of the reception year, teachers are required to complete something called the Early Years Foundation Stage Profile. So we timed our screening to co-occur with that. As luck would have it, the year that we got the money, the government announced it was going to change the Early Years Foundation Stage Profile. So we got the DFE to give us the new version. So the poor teachers had to do the old and the new version of the Early Years Foundation Stage Profile and our screen, which I'll tell you about in a minute. So children were in the summer term. It all happened in the summer term. They were between 4'9" and 5'10". We had complete screening data in the end on 7,267 children, which is about 60% of all kids who started a mainstream classroom in Surrey in 2011. Pretty even gender split. 82% were of white British ethnic origin, which was fairly representative of England at the time. 11% had English as an additional language, so that was a bit lower than the UK total, but still quite a huge sample of kids speaking English as an additional language. And surprisingly, even in Surrey, 64 different languages in the population that we sampled. Of course, we are skewed toward more affluent population here, but we did have representation from across the range. The primary screen was a short form of Dorothy Bishop's Children's Communication Checklist. And so it had 13 items. It covered a full range of language. So there were things about speech, vocabulary, sentence processing, narrative, pragmatic language. And teachers were just asked to rate how often children engaged in these sorts of behaviors on a daily basis. And the scores ranged from 0, which was everything's fine, to 39, which meant that the teachers reported the children weren't speaking in two-word combinations or short phrases at the end of their first year of school. So 39 is the most severe. You have kids on this axis, and the dark bars are the boys, and the light bars are the girls. You can see here the first thing to say is that it's a fairly continuous distribution at the tail. We had 6 weeks to turn this around, so we had lots of chat about where we were going to draw our arbitrary cutoff. We anticipated that here you would have kids who had very complex needs. If you were going to find children with specific language disorders, we thought they'd probably be around here. So in the end, we drew a cutoff at 14%. So this is the 14% who are rated to have the most significant language needs in this population. So if you are still awake, you will notice that there are a lot of boys in the tail. So teachers are rating boys as having less competent language at a rate of 2 to 1. There are a lot of summer-born children in this bit of the tail. They're younger, they don't have as competent language, so that's fine, but it's not good for their early years foundation stage profile. And it identifies about 39% of the children with EAL. And I think one of the more surprising things that we found was that 1% of our sample were rated as having no phrase speech at the end of their first year of school, and they are in reception. And if you know anything about the reception curriculum, those kids are really, really struggling. Okay, it's very hard indeed, both to access the school curriculum, but also to access your peer group when you're not speaking in sentences. So we had 6 weeks to turn it around. Unfortunately, couldn't assess all 7,000 children in detail. So this is what we did. By the end of that year, 31 children were on their way to a specialist school. We didn't see them because we didn't think they would be able to access our assessments. We didn't put the EAL kids into this mix. We did a pilot study with a PhD student called Katie Whiteside. She's published a couple of very nice papers on that group. They're really interesting. We then stratified our sample by sex and by season of birth and by their scores, so whether or not they came into our high-risk group. So these are the low-risk kids, high-risk kids, and the no-phrase speech children. We invited all of them, and then we oversampled girls, and we oversampled high-risk, and then did a random draw from those pots. We invited 636, 107 said no. We assessed 529 in year 1, 499 in year 3, and we've just finished seeing about 400 of them in year 6. But I won't tell you about them today. Okay, so what did we find? So the first thing we did was to try to operationalize language disorder, and we used the same framework that had been used in previous epidemiological studies, particularly Bruce Tomlin's study. And so this measures vocabulary, grammar, and narrative in comprehension and expressive formats. So you end up with 5 composite scores. We also measured nonverbal ability using block design and matrix reasoning. Our criteria for language were somewhat more severe than Bruce Tomlin's because we already knew that his criteria picked up many false positives. So we identified language disorder as being in the bottom 7th percentile on 2 out of our 5 composite scores at least. Our nonverbal IQ was more generous though, so you only had to score above the 3rd centile, and that was developmental language disorder. So what happened then is that we reported prevalence, and what we found was that 7.58% of kids met those criteria and didn't have any other diagnosis. And if you split it into those who would be specifically language impaired and that their IQs were within the normal range, that was 4.8%, and those with the lower nonverbal IQ band were 2.78%. So including those children does increase your prevalence estimate, but they were always there in the population and they have needs.
Now, one thing we didn't do was to exclude everybody else, and I'm really glad we didn't, because they turned out to be really interesting. So this group meets our criteria for language disorder, but they have an additional diagnosis. And because we have a population study, we have just about everything in there. Mostly children with autism, but we also have children with Down syndrome, cerebral palsy, chromosomal anomalies, you name it. There's lots of very interesting children in there. So overall, just under 10% of the population have this level of language difficulty, and we measured functional impact using those standard education assessments. And so we know that those children who meet our criteria, fewer than 10% of them achieved their early learning goals on the early years foundation stage profile. So that level of language difficulty when you start school means that you're not meeting curriculum targets from the word go. The next question was whether relaxing this nonverbal IQ criteria make a big difference to your clinical profile, and the answer is largely no, interestingly. So these are the children who, I often would say they were in no man's land, so they're excluded from other studies and excluded from language units, compared to the ones who would meet the more SLI type criteria. And these are the children who have additional diagnoses. This is the ADACI rank, so this is a measure of SES. You can see no differences here, but these scores are much lower than the typical kids. So even in this relatively affluent sample, we do get SES effects, and that children with language disorders tend to come from more disadvantaged backgrounds. This is the score on the screen. This is the Z-scores on the overall language composite. This is the percentage who have clinically significant levels of social, emotional, and behavioral problems on the SDQ, Strengths and Difficulties Questionnaire. This is the raw score on the early years foundation stage profile. So you can see that really there's no difference at all between those two groups. If you have a language disorder that occurs in the context of another developmental condition, though, there's more severe impairment across the board. And this one's quite interesting because you can see that overall only about half of the kids that we identify get referred to speech and language therapy services. A lot of debate about what this is about. It's quite a complicated thing. So one thing to know about Surrey at the time was that they had two healthcare providers who were providing speech and language therapy services, and they did very different things. So one offered a universal only provision, so they only came in and assessed children and gave advice. The other ones did provide treatment, but it was a bit patchy, so that's one issue. The other issue is, I think teachers know when there are difficulties with the child. They might not always attribute it to language, so they might think it's a behavior problem or a reading problem. Even when they know it's language, if they're not going to get a service, a lot of them would say, there's no point in me filling in all that paperwork, because by the time we get to see, the child will have moved on, so I'm not doing that. Sometimes they would say, well, we want to refer them, but parents aren't ready yet. So parents don't want us to refer, they don't want to go down that road. So only about half the kids go at this point in time, but it's for very complex reasons. Okay, so what happens over time? So this is in year 3, and what I'm doing here is plotting language scores in year 1, Z scores, by language scores in year 3. These are the cutoff scores, so this is minus 1.5 standard deviations below the mean. Each of those dots is a child. If we had a perfect relationship, all the dots would be on this line, and this interclass correlation coefficient would be 1. It's 0.95. It's about as good as it gets. Test-retest reliability, which is a week later, would be about 0.97. So actually what this is showing is that language is incredibly stable once you get to school. You can predict pretty well from your language scores in year 1 how well these children will be faring in year 3. It's very, very stable indeed. We aren't the only ones to report this. So this is Mark Bornstein, who works at NIH in the US, and he's done quite a number of studies now in different populations, children who are at biological or social risk. So lots of studies of kids who've been through Head Start,
children with contrasting language skills, so ones who look like they have language disorders and ones who are typical, using different measures, different domains of language, different informants, and every study says the same thing. Once you get to school, language is incredibly stable, and that stability maintains even when you take account of things that you think might influence stability, like level of maternal education, maternal language, home environment, the child's nonverbal IQ, and their social behavior. So language is pretty stable. Now, again, if you're alert, you might notice, well, hang on a second, there's some movement here. So what we see here are some children who look like they're doing a bit better in year 3 than they were in year 1. But you get an equal number of kids who look like they're doing a bit worse. At this point, everybody says, who is getting speech and language therapy? At which point I say, our study is not set up to evaluate speech and language interventions, and it's very hard to know exactly what people got. But we do know that about half of this group got referred, at least, or about half of that group got referred to. And what we think is that you can see that most of the movement is around the cutoffs. We think this is mostly to do with measurement error. And about the same time we published this study, Christina McKean in Newcastle published a longitudinal study of the Australian cohort. And they used a statistical technique where you can get rid of that measurement error, basically. And they looked at growth trajectories between 4 and 11. And what they found was that 94% of children in their population sample had a stable trajectory. So they were either stable high, stable low, or stable in the middle. Only 2% started low and got better, and about half of them were children learning English as an additional language. So really, across the whole population, about 1% showed greater than expected progress in language. But I don't want you all to get depressed. This is usually the point where everybody gets depressed. Don't get depressed, because they are all improving, okay? And the best thing about our study is that we show that this group at the bottom are improving as well. So these are the children that have language disorders and all these very complex additional needs. So what I'm showing you here is change in raw score, not in standard score. This is age in months, this is year 1, this is year 3, and this is the raw scores. So here you have the typical kids. We can only model a linear trajectory because we only have 2 points in time, but they're all shooting up. These are the kids with language disorder, they're moving up, and these are the kids who have multiple challenges. They're improving as well. So everyone's improving, and astonishingly, as a group, they're all moving at mostly the same rate. And really, this is what good universal education provision does for children. It teaches them things. They learn language, and it's brilliant, okay? Great. Now, when Gillian Baird looked at this graph, being the pediatrician that she is, she said, that looks just like a height and weight chart. And that really made me think hard, because I was kind of scratching my head going, how can language be both stable and improving at the same time? That doesn't make any sense. But when she said that, I started to think about height, because height is another trait, another developmental trait that is both stable and changing. So this is how I now think about language, right? So if you have a little 4-year-old and you measure them every year until they're 11, they get taller. If you got a whole class of 4-year-olds to line up according to height, which they like to do, you will find that there are some relatively short children and some relatively tall children. If you measure them all again in year 6, they're all taller, but this child who is relatively small is probably still the smallest child in the class. And this one who is relatively tall is probably still the tallest child in the class. And you might have a little bit of movement in the middle, but essentially that rank order is preserved. And that seems to be what's happening with language. Okay, so the ones who are struggling to begin with continue to struggle, and I think any teacher would recognize that. Yeah, so a bit like height. So you might be interested in what predicts slope. The things that we measured at intake were socioeconomic status, nonverbal IQ, and these social, emotional, and behavioral problems. They are all associated with the intercept. So children who had the poorest language abilities also tended to come from more disadvantaged backgrounds, have lower non-verbal IQs and more behavior problems. But none of those things was associated with growth. Okay, so none are predictive of growth. And again, Mark Bornstein finds exactly the same thing. So, again, at this point, lots of people feel a little bit down. But think about height, okay? So, language and height, they're both distributed in the population. We have arbitrary cutoffs for the extreme scores. So I like this graph that says tall, kind of tall, extremely tall. Yeah, just a bit like language disorder. Highly heritable, like language, highly stable. Nevertheless, even height is ultimately subject to environmental influences. So this is a really cool paper that was published in eLife in 2016, showing that over the last 100 years, everybody in the world is getting taller, okay? So the tallest men now are in the Netherlands. Who knew? The men who had the biggest height gain over the last 100 years were from Iran. The biggest height gain for women was in South Korea, and the world's tiniest women are in Guatemala. Okay, so everybody's getting taller. Nevertheless, you still have relatively tall populations of people in the Netherlands and relatively small populations of people in Guatemala. Now, I bet none of you think that height is malleable. The reason you see this population change is because of things like improved nutrition, improved medical care, improved sanitation. So you can make a change at a population level, but it's very hard to change those individual differences. And if we're going to make a change in language, I hope it won't take us 100 years to do it. I hope we can do it a bit more quickly. Okay, so there are definitely challenges that arise once we accept that language is quite stable. And the first one is this. If you have improvement that is parallel across the distribution, then narrowing a gap is a really hard thing to do. So if you look carefully here, you will see that our kids with language disorder are finishing year 3, where the typical kids start in year 1. And essentially what that means is you have a 2 to 3 year language gap between those kids who are at the top and the bottom of the distribution. And there's plenty of work, at least with this red line, that suggests that gap maintains all the way into adulthood. So narrowing the gap is hard. It's also hard if you want to understand causal relationships. So, you know, lots of people would like to know whether having lower nonverbal cognition early on influences your language ability in later childhood. Same thing with SES. I could put executive function in here, anything you want. And if you do it this way, you will see that these things are associated with language outcome. But once you put the autoregressor in the model, those things fall out, because the best predictor of later language is almost always earlier language ability. So that's pain. It's pain when you do those models. It all falls out, it all falls out. There's quite a big debate about what developmental changes in stability mean for theory and practice. So Matt asked about individual prediction, and it's not good. It's not good in infancy. It's not good in 2-year-olds. In fact, stability estimates before school only ever get to be as good as about 0.5, so 25% of later variance explained. And in fact, most studies would suggest that this age, particularly before 2, is far too young to identify in children. Screening doesn't work unless there's a problem, because ideally what you want to do is identify those kids who have problems early on. But what does it mean? So some people have argued, Mark Bornstein is one of them, that this instability might signify a golden period of developmental plasticity. So get in early, offer early intervention, and you'll sort the problem out. I think there probably is a group who are stable from that early age, so from 15 months. But on top of that is a lot of normal variation. So trying to pick out the ones who are going to go on to have continuous difficulties is very problematic. And the other thing that really contributes to instability at this age is measurements. Our measures of language before the age of 3 aren't as reliable as they are later on, and that's going to contribute to this instability as well. So it could just be noise rather than anything indicative of a really golden opportunity for change. The interesting thing is once kids get to school, which varies across the world, but most studies say that from about the age of 4, you can get very stable estimates of language. Then you've got the problem that things just don't change, right? Your stability estimates exceed 0.85. And why is that? So we have got better measurement. I think that's a key thing. And in scales particularly, we've used the same tests at both time points, which is probably why we have such strong stability. But you also have a lot more consistency in environmental experience. So we have schools, say what you like about it, you know, we've got great schools and we've got a national curriculum. So the experience that kids are having when they get to school is a lot more homogenous. And actually we don't have that many studies of language change in adolescence. There's really exciting work now looking at learning and capacity for learning in adolescence, and that's all showing that adolescence might be a sweet spot in development to make cognitive changes. So it is possible that language could change. We know that the brain is changing during adolescence in language relevant areas, so that could be another sweet spot. So like I said, we've just seen kids in year 6. I would say by year 6, most of the children in this green line are in a specialist education provision now because they can't keep up with their peers. My prediction is that this red line will continue to go parallel, but this one might start to plateau. The question is why? So it could be that there's just a biological limit to what they can learn. It could be that the fact that they are now in special provision, almost none of the children in that green line could read when we last saw them in year 3. And we've shown that they have quite significant peer problems from the time they start school. So what they're learning is probably quite different now to what these children are learning. And the other thing about adolescence is the nature of the language you need changes. So it becomes much more complex, much more abstract, much more removed from the here and now. So it could be that that just exceeds the capacity that they have. That's my prediction. We'll see what happens. Right, so I think that kids learn language. Obviously they do, even when they have numerous developmental challenges, but I'm not sure that we can accelerate the rate of language learning. So what does that mean for practice? It means that this is hard. So normalizing language, moving kids into the normal range, getting some kind of statistically significant improvement on a standardized test of language is going to be very hard work. Because in order to do that, you need these children who have a biological predisposition to find language learning hard and are likely to come from more disadvantaged backgrounds. They have to learn at a faster rate than my daughter, who has every advantage going for her. Some people say it's like trying to catch a moving train. These kids are they're just powerhouses of language learning. So this is a really tough job. I think what we possibly could do is narrow this gap. So at the moment I said it's 2 to 3 years' time. If we were to intervene before they get to school, could we just narrow that to be 12 months maybe? That would make a huge difference to their ability to access school and peers. I think the best time to probably do this is preschool. The problem with really, really early intervention is you're probably intervening with typical kids. And many studies that have been very rigorous show no difference between intervention and control groups, not because no one improves, but because everybody improves and the control group improved just as much. So probably somewhere around preschool intervention would be what I would be looking at. And there is some evidence that you can do this, but the studies that have been most successful have really spent a lot of time trying to do it. Okay, it takes a lot of time and it takes considerable effort. So I often say I am
regrettably a very monolingual person. And so I always look out to those of you who speak more than one language, and I want to ask you, how much time and effort did it take for you to become proficient in your second language? I bet it was more than 6 sessions of foreign language learning. Was it? Yes! Probably daily practice for years on end, okay? So if we're really serious about narrowing that gap, we've got to invest some time and effort in doing it. And even if we do that, there will still be someone at the bottom of the distribution. Whatever Michael Gove says, it is not possible for everyone to be above average, okay? So you've got to think about what that bottom of the distribution looks like. Now, we could not, in any ideal world, offer speech and language therapy every day or run language groups every day. That would probably not be desirable for the young people themselves. So what I've been trying to think about is how you, one, ensure that the children who are really having problems have at least a functional level of language communication and literacy. So where I'm a governor, we had 4 children in reception a couple of years ago who were nonverbal. Nobody in the school did any kind of sign or any kind of alternative communication. Those kids just cannot access their friendship groups or their curriculum or communicate even their basic needs. We can do better than that. But for everybody else, I think, are there push points where you really need to load up that special extra support? And these are just some that I've thought about. Okay, so we talked about preschool. That transition to literacy is hugely important. Literacy is founded on oral language skills. If you ask parents, they say this is where everything went horribly wrong, and that's just the point where we withdraw specialist clinical services for children. And because we now know it's a persistent lifelong disorder, some support for kids when they leave school so that they can have jobs and be functioning members of society. The other thing to think about is how we measure success. So one thing is to think about academic outcomes that are going to help them make that transition to adulthood, and non-language things like their mental well-being, their social skills and social successes. So really to think about these cascading impacts, because children with DLD become adolescents with DLD and then adults with DLD, and these are the things we know that they are at risk for literacy, greater rates of unemployment, problems with peers, and increased risk for poor mental health. So a key priority of our language interventions might not be to normalize language, it might be to reduce risk in these areas, and that would greatly improve quality of life. So, I'm on the concluding slide. I think that my study, far from being depressed, I feel quite cheered, because I think at least now we know what we're dealing with, we can make a plan. And what we need to plan for is the fact that we can't cure language disorder, but we could make people's lives a lot better. But in order to do that, we have to really think seriously about the support we provide from the early years through to adulthood, and accept that narrowing the gap without targeted, intensive, and persistent support isn't going to happen. So if that's what we want to do, we need to get serious about how we do that. And that regardless, these children probably require ongoing support from multidisciplinary teams, great education, and specialist services in order to mitigate the risks of those cascading and negative impacts of language disorder. So that's all I have to say for now, but if you want to know more about language disorder, we have this fantastic YouTube channel. It's got loads of videos of young people themselves talking about what it's like to have a language disorder, and lots of resources for parents and teachers and the children themselves. Thank you very much for having me.
Thank you very much. That was very, very exciting. I mean, I didn't get too depressed.
Good.
I want to go back to some of the biology. I find your comparison with height very interesting.
Yeah.
But of course, there are differences as well.
Of course there are.
I'm just thinking, because with height,
there's this whole catch-up process. So you know, if somebody, it's exactly the opposite. So if somebody's deprived, you know, below the 25th percentile at 3, catch-up growth can make them on above and so on. We know that perfectly well. There's catch-up and catch-down growth, which is quite striking. And I'm just wondering why, in a sense, you're saying there's no catch-up or very little catch-up and catch-down in language.
Yeah.
And I can just sort of premise that. There's a very interesting paper a few years ago, which I can't remember the exact figure, but there's something between 200 and 400 genetic loci associated with height. And it only accounts for 25% of the variation in height. So there's a, so in a sense, there's a matrix there of genetic complexity and environmental plasticity.
Yep.
I just wonder, is there anything in the linguistic world that might...
So, yeah, so there's lots in there. So the genetics is probably equally complex, right? So most of the studies are saying multiple genes, each exerting a small effect. We have no idea how they interact with each other. They account for very little of the variance. But what they seem to be doing is altering the way in which the brain is developing in systems that support language learning. In terms of catch-up, in this kind of typical situation, you don't really see it, but I can think of one study, which is the studies of the Romanian adoptees, where you do see that kind of catch-up, but that's in a really extreme setting where you have extreme deprivation, and then you move kids into the UK where they then get all these advantages. And there, they did show some catch-up, depending on when they moved the kids. So it can happen, but it's quite a rare thing and not in this kind of typical population.
I mean, I suppose the obvious inference is that there is the genetic variance or genetic impact is much greater in language, or it's not quite the same thing. There's less plasticity in the system because there's much more, I guess, sort of pleiotropic effects.
Potentially, like yeah. So you can see it, but it's not the norm.
I agree that intervening early should be the best way to do. In that respect, I think that bilingualism could be an intervention, in that there are some data showing that children growing bilingual with language impairment do better on some tasks than monolingual children. And other intervention studies, for example, have used sign language. I mean, there is nothing very systematic on that area, but I think that it might be worth considering, along with music, probably.
Right. So, I don't know, it's certainly not the case that being a bilingual makes your language disorder any worse. I don't know that kids who are bilingual and have language disorders do better than monolingual kids or other bilingual kids. In Katie's study, she showed that basically, and again, it's very difficult because it's hard to diagnose language disorder in the groups that we have because we don't have good measures in the first language. But we certainly had kids who were reported to have 2 languages at home who were in the bottom of the distribution, and those who were at the top. And again, they grow in parallel. So even though the ones at the bottom are making progress in English, they're still at the bottom of the distribution when they got to year 3, but that's quite a mixed group. The ones who are at the top did do better than their monolingual peers on a number of indices, but the ones at the bottom, they looked more similar to the kids with language disorders. There's variation though, because some of those kids have language problems and some of them just need more time to learn English. Don't know about music. Don't know. Lots of hands, so wait for the microphone.
I was thinking about your point on intervention and how hard it is to identify who's going to need it and how to narrow the gap. But another model or another way of selling this to people who could fund interventions is that you could try and move the whole population along. So you do an intervention that's going to help language for all children, with your aim being to bring that tail into the functionally competent range, and it doesn't matter if some children benefit who didn't need it in the first place because you've shifted the whole population.
Yeah. So that's a really interesting point, and I think that's what a lot of our speech and language therapy services want to do, just provide universal. That works if you assume that kids with language disorder learn in the same sort of ways or will benefit from the same sorts of things that other kids will, and that's not necessarily the case. So by just focusing at a population level, you might be widening the gap. So that's a really interesting question.
It's unlikely you'd widen the gap on your data. So I was expecting over time your sort of deficit group would be falling away, but you've got them always keeping up so far.
Yeah.
Which is surprising in itself.
Yeah, with that group, but I do think they will plateau because they can't keep up, and it's certainly the case that they can't learn in mainstream classrooms anymore. So it's hard to imagine a universal thing that will move them up at the same rate for a long period of time. In a mainstream classroom. I do think they need something different. Yeah. There aren't many studies where, so one approach to intervention is to do things like train teachers or train nursery providers to have better language skills in the classroom. Yeah, well, exactly. In terms of individual outcomes for a child language, there aren't very good reports of what happens, and what's out there is quite mixed. So some studies show that if you do really intensive, almost like co-teaching between language specialists and the teachers, you can shift child language. Some of them show no effect at all. Depends on the level of skill of the teacher sometimes and the intensity of the intervention. So yeah, I agree. Lots of people want to do a universal thing. I think that's fine, but I do think there are kids who need something different and something additional.
That was really wonderful.
Thanks, Matt.
So I've been thinking about something that I understand is different from when I started school, which is everyone in a year group starts in the same term. Thinking about the relationship between that and the very large effects of age that you were showing. I'm wondering do you think that a policy change there would make a difference?
Yes, but probably not the policy change you're thinking of. So, there are lots of things that happen that make life difficult for 4-year-olds going to school in England, okay? And one is we are total outliers in sending our children to school at 4 and expecting them to do things like read and write and sit down and learn and do things like that, okay? Total outliers. I think we're like one of 5 countries in the world that do that, okay? So what does happen is in other countries, particularly ones we aspire to in terms of their education outcomes, they have excellent nursery provision, okay? So they do send their children to nursery at 4, but they have highly qualified people in the nurseries who develop oral language skills through play and through developing peer interactions. So my view is that if you want to send our children to school at 4, there's good reason to do that. But do something that's developmentally appropriate. What we do is we send them to school at 4, and most classrooms stream kids almost instantly, okay? So if you go into reception, there's a top table, there's a bottom table. You might not know much, but you definitely know whether you're on the top table or the bottom table. And is there anything less motivating than being on the bottom table, right? It's really hard. Really hard. And studies that have looked at this relative age effect show that by year 3, that effective age has attenuated. It's still there, but it's attenuated. But those young kids do not have confidence in their learning the way the older kids do. So what I would do is say, send them to school at 4, send them all at the same time, but focus that early reception year on developing oral language and leave the other stuff until later. And then everybody's got a reasonably good foundation. And in terms of universal provision, I think that's probably the best thing that we could do. The government decided that we should let everybody have their own choice And that's problematic for lots of reasons. So you will know this, right? How expensive is nursery? Nursery, a year of nursery is more than university tuition. It was more than my mortgage. We were quite happy to send our summer-born child off to school. But if you have the economic resources to hold your child back a year, then that's what you do, and that's what happens now. So at a population level, it exacerbates the SES effects on attainment. But you would be amazed, so we wrote a big article about this, you would be amazed at the vitriolic emails I got about saying, don't do that, you know. Some people say, quite happy to say, but I want my child to be advantaged. There you go. A hot potato, man, a hot potato, that's what that one is.
Hi, thank you for the talk. So I read there's a paper from the Center for the Developing Child at Harvard, a white paper about the science of neglect.
Yeah.
And it is kind of talking about a lot of correlations with some of the same factors that affect your slope. Intercept.
Yeah.
So do you think that approaching it from that perspective, like focusing on those groups in the early intervention periods, could lead to shortening the gap, but furthermore, still ensure that the gap doesn't widen because you're talking about the plateauing. So what are your thoughts on that?
I totally agree. So, but again, we're talking political hot potato here, right? We know who is going to have problems. So a really fascinating paper by Caspi, and using the Dunedin cohort. And basically they showed that at 3, you could take measures of language, basically measures of language, some of self-regulation, I can't remember what the third one was, but it was basically language or language-related stuff at 3. If you took the bottom 20%, you could predict the 80% of kids who were going to be adults who cost you a lot of money, okay? But only if you were having those problems in the context of extreme social disadvantage and family chaos, okay? So the kinds of families you're talking about. So when you had language disorder occurring in those contexts, those children would go on to be the ones who were committing crimes, who were unhealthy because they weren't making healthy choices, who had loads of special education, which was very costly. So we know who is going to have persistent difficulties. If you want to target your early intervention, that's where I would do it. It's a very hard group to engage, and they're not ones who like to take part in my research studies. So but it's a challenge, and I think universal screening is going to waste a lot of time and money because you're just going to pick up loads of false positives. But if you did targeted screening, then you might have a more productive hit rate. But you've really got to think about how you engage those families and the kind of long-term support they need. But I definitely think it's worth doing. And I think too, because you know, when I had my daughter, I remember clearly a day where I was like, what am I going to do with this baby all day long? You know, and it's only because I'm highly educated and a speech and language therapist and interested in language. I went, well, I could just like describe what we're doing. So yeah, I just walk around talking to this baby all day long. Eventually it felt okay, but I remember doing it originally thinking, God, this is just so weird. And I thought, you know, if you were a young teenage mum who didn't have good social support, who didn't have that experience of people talking to you as a child, who didn't think about the fact that young babies learn language, you know, it would never cross your mind to do that. So some kind of interventions that really support young mums to do baby-friendly things, I think would also be a really useful thing to do. Oops.
I think that, okay, there is a last question. I think we should just have one. Okay.
On that note that you were just talking about, I worked on a study where we were providing coaching to parents, but this is for children who are at risk for autism.
Mm-hmm.
And I know you were saying that with really early intervention, it's difficult to know who's going to have a language impairment.
Mm-hmm.
Is there a way to do early intervention with parents where we provide coaching on social communication or strategies like you're talking about with children who are at risk And would that be doing that?
So I know Helen Tager-Fussberg in the States was trying to do an at-risk study that involved kids with language disorders, but I think she's had just a total nightmare trying to recruit them. I think there might also be a study in Finland doing this. I mean, I think the difficulty is that often, not all parents by any stretch of the imagination, but many parents who have children with language disorders have difficulties themselves and have quite complicated lives. And taking part in those things, just not something that comes onto their radar. But I do think there might be ways to think about how, through health visiting services or something like that, you can pick up vulnerable families. So it might not be the same sort of design as ASD, but I do think you could pick up vulnerable families and track their progress over time.
Thank you.
Well, I think at this point we should thank our speaker. We have now reached the end of the symposium, and before we go